Can you still hear me? Is that still? Because I will shout, I will get excited, and I'll start shouting, and everyone will go deaf. Right, okay, so this room is actually double booked in our program, so if you're here for a talk on cloud-based detection and botnets, then this is the right room to be in. If, in fact, you're here for extended security on Xcode, then you need to be across the room in Lab 002. So this is your last chance to escape. Otherwise, we're going to talk about malware detection in the cloud. So your last chance. Thanks for coming. Right, okay, let's get started. Okay, so welcome everybody. Welcome to the conference. My name is Mark Graham, and as I said to you a few times now, I am going to be talking to you about cloud-based detection techniques. We're going to be talking about some techniques that we all know, we all use, we all love for detecting botnets and malware, and we're actually going to see why some of these techniques aren't quite as robust as we think they are. And then I'm going to end the talk with just a little bit about some of the techniques that we're studying here at Anglia Ruskin University. So, problem number one, how do we change the... help someone from AV? There we go, cool, got it. Right, okay, so as I say, my name is Mark Graham. I'm a PhD student here at Anglia Ruskin, and I'm studying the behavior of botnets and other malware in virtual environments. And part of what I'm doing is I'm actually looking at anomaly detection, traffic-based techniques for detecting malware. So we'll talk a little bit today towards the end about some of the research that we're doing here at Anglia Ruskin, not just in botnets in virtual environments, but some of the general research that we're doing here at Anglia Ruskin. Oops. Okay, so today we're going to talk about the way that malware is evolving. Malware's evolved very much from the early days, and as our programming techniques, as our networking communication techniques, malware has evolved along those techniques as well. So we're going to talk a little bit about the way malware's evolved. We're going to talk a lot about botnets, because botnets is what I'm studying. Botnets is what interests me, so you guys are going to hear a lot about botnets as well. We're going to talk about some of the weaknesses in traditional, what I call antivirus software, the signature-based malware detection that we all have on our PCs, on our firewalls, on our servers. We all use these every day, and we're going to talk about some of the weaknesses for exploiting that. And then we're going to talk a little bit about some of the alternatives, some of the signature-less detection techniques that are out there available today. When you study, academically, when you study malware, malware detection, it's split into two camps. So you have signature-based malware detection. So that's where we're getting a sample of malware, and we're analyzing that malware to come up with a kind of a fingerprint for that malware, and then we're looking inside of packets, inside of programs, memory, and packets for those signatures of that malware. So that is very much at an application level. It's very much a packet inspection technique. And then the other side of the coin is what we've got is anomaly-based detection. So anomaly-based detection is more looking at the behavior of malware rather than looking for a specific fingerprint. So that's very much more at a traffic level as opposed to an application level. So we're talking layers 2, 3, 4 as opposed to application level, which we're traditional antivirus software has been very much involved in. So we'll talk about both of those today. Okay. So malware's changed over the years. I'm going to ask a question now. Hands up, anybody who knows what the first malware, the first virus was, and when it came out. Anybody?
It was developed in Pakistan, wasn't it?
What do you think it was?
What's that?
Well, do you know what do you think it might have been?
I heard it on the news.
Right. Okay.
It was a set of brothers who were living in Pakistan, at least according to this station. It might have not been the reality.
Okay. Well, according to my notes, I'm not sure if they're right or not, but the first recognized malware was back in 1971. It was the creeper virus, and it was a piece of self-replicating code that attacked DEC machines. This is how long ago it was, and it was actually propagated over ARPANET, so pre-internet days. So this was a long time ago. A virus is simply a piece of self-replicating code. That's all it is. And viruses don't have to be malicious. Most of them are today, but it's just a piece of code that will replicate itself. So these first viruses very much relied on human intervention for them to propagate. So they rely on somebody infecting a PC, someone taking a floppy drive, as it was back then, and inserting that into another machine to propagate. So these viruses were very reliant on human beings to spread them. As communication and networking techniques evolved, viruses changed into the worms and the Trojans that we know today. And the difference really now is that we're using networks to propagate this malware. So things like email attachments, downloads, clicking on spurious links on the internet, those kind of things. So the way that the malware has propagated over the years has changed somewhat. And then today we have kind of a third generation of malware, which is botnets. And these botnets differ very, very differently to worms and viruses. And that botnets rely on mass attack, mass coordinated attack on a single victim. So viruses and worms and Trojans, they very much infected one machine, did what they need to do, and then moved on to the next one. Whereas botnets, they'll sit together, they'll work to become a mass of compromised machines and attack accordingly to what they're designed to do. I think the popularity today, botnets are a very, very serious problem today in IT security. And I think the popularity of botnets comes because some of these free do-it-yourself, build-it-yourself botnet kits that you can get on the internet. So Zeus botnet, Zeus malware is a very, very popular a botnet, which you can just go down, download off the internet. Even someone like I can do that. I can download the source code, create my own botnet, and away we go. So these do-it-yourself crime tools, where they're very, very accessible. You can pay for the latest version, or you can download the earlier versions, and you can create your own botnet. So that's what's driving botnets, making botnets very, very popular today. And another statistic for you before we move on. SANS did a piece of work earlier this year to look at how long it takes a brand new unboxed PC connected to the internet to get infected with a virus. Anybody want to guess how long it would take? Brand new PC, plugging it into the internet. How long is it going to?
5 minutes.
Who said 5 minutes? 5 minutes, exactly. 5 minutes is all it takes for a brand new PC. So that's, you've plugged it into the internet, you haven't even finished downloading your updates yet, and on average, you are infected with some type of virus. So viruses are very much a very, very big security problem for us today. Oops. Okay, so what this diagram shows is a very, very simple topology of a botnet. Hopefully some of you guys are familiar with botnets and know how they work. But as I said earlier, botnets differ to normal malware in the fact that with botnets you have a whole network, a whole army of compromised machines. And whereas a normal virus, a normal Trojan or worm or virus will infect a machine, do what it needs to do. That might be a keylogger or delete a file or encrypt a file. It will do what it needs to do. Then it will try and propagate onto another machine. The way botnets tend to work is they might get compromised, and they might not do anything for a while. But what they're doing is they're waiting for this botnet to get bigger and bigger and bigger and build up a kind of a mass, an army of infected devices. And botnets can vary in size anywhere from a handful of botnets, and the average size botnet is somewhere around the region of a couple of 100,000 botnets. The problem is, as you become bigger and bigger and bigger botnet, the easier it is to be detected. So botnets try to limit themselves to a couple of 100,000 devices. Now, these devices are operated at the top there by a human botmaster. So it could be a number of botmasters, but these guys are the ones that are controlling these botnets through one or many servers, and they're controlling what these guys are doing here. So they might be waiting for an attack, and all of a sudden they'll launch a mass attack. A couple of 100,000 botnets will do an attack of some sort on an unexpected victim. So that makes these guys very designed for specific types of attack. One of the biggest attacks that these guys are known to do, botnets are known to do, is spam and denial of service. When you think about it, you've got a whole bunch of these machines, very easy for them to send out a whole bunch of emails or broadcast a whole bunch of bandwidth hogging denial of service attack. And it's estimated that somewhere in the region of 60% of internet traffic comes from botnets doing spam and denial of service. And that to me, that's a big figure, that's a hell of a lot. The other thing that botnets are very much designed to do is ID theft. So hopefully most people here in the room have heard of Zeus. Zeus was a banking Trojan, and what Zeus does is it installs a keylogger, and it sits there silently on your PC, and every time you log onto a bank or log onto the internet and Facebook or LinkedIn, whatever you want to log into, it's going to record your details and send them back to a command and control server. So it was estimated that last year, 2013, somewhere in the region of 900 different financial institutions were affected with the Zeus malware. So again, I think that's quite a scary number. And the kind of third attack profile that these guys are ideally designed for is click fraud. So you've seen on the internet where you will click on an advert and it takes you to a web page. The owners of that web page get a penny or a fraction of a pence for you clicking on that link. If you can get a whole bunch of these botnets just constantly clicking on these links all day, you're going to earn yourself some money. And an average size botnet, maybe 100,000 bots in a botnet, will earn somewhere in the region of $1 million a month on click fraud. So again, that's quite a scary number. The advertising industry reckons that somewhere, depending on what reports you read, somewhere between $100 and $400 million a year is being lost to botnets through click fraud. So this is the serious problems here that we need to address. But don't get me wrong. Not all botnets are bad, you'll be glad to hear. Just maybe 99.9% of them are bad. And a bot is simply a robot. It's just repeating a repetitive process. That's all a bot is. So companies like Google use bots to crawlers and spiders to index the web. If you've got a lot of data to index, like SETI, for example, they use bots to search for signals of extraterrestrial life. So don't go away thinking all bots are bad. Just the huge majority of bots are bad. Not all viruses are bad. The huge majority of them are bad. So take that message away. Come on. Okay, so traditional antivirus software, as I alluded to a little bit at the beginning, relies on us getting a sample of that malware. That could be through something like a honeypot. It could be through someone getting a compromised file and sending it to an anti-malware researcher. But first of all, we need a sample of that malware in order to reverse engineer it. Now, very often that malware is encrypted, so we need to decrypt that somehow. We then reverse engineer the code, and we're looking for certain signatures in that code to go away and create a fingerprint of that specific malware. We then upload those fingerprints to antivirus software, and you're protected. Now, the problem with that is the time between releasing malware into the wild and actually creating that sample and uploading it to your antivirus software could take anywhere between a couple of days. Sometimes it takes weeks, sometimes it takes months. So there is a period, there's a window where your antivirus software is not protecting you because we haven't got a sample of that virus. We're relying on a signature fingerprint of that virus to detect it, and we haven't got that virus. So one of the biggest issues with signature-based detection is that period where it's not where we haven't got the sample to be able to detect it. Now, it's a lot easier for malware authors to change the code than it is for these guys to go for researchers to collect the sample and create a signature. So it might take a malware author a couple of seconds to change its code, the binary of the botnet, enough that the actual attack vector hasn't changed. It's still doing exactly the same attack, but the binary has changed enough that the signature-based detector doesn't recognize it anymore. And so one of the simplest techniques that the malware author can use is they can change their compiler settings, recompile exactly the same code, and they've got a big enough change in the binary that signature is no longer recognizable, and we need a new binary, a new signature of that new variant to detect it. So some of the other techniques that they can use is they can use noise at the beginning or the end of the binary to change the profile, or they can just insert some pointless code. So we could put A equals A. It's a piece of null code. It doesn't mean anything, but that is enough to change the definition of the virus enough that the antivirus detector won't pick that up anymore, and we need to create a new sample. So one of the other problems that we've got with signature-based detection is it cannot cope with malware variants. It struggles with making a slight change in code. We need a new signature in order to detect that. So we use what's called heuristic detection. Now, heuristic detection is really a less exact way of detecting malware. Rather than looking for a specific fingerprint, we're looking for similar traits amongst malware. So I was trying to think of an analogy. So rather than looking for a fingerprint, we might say that all malware has 4 fingers. Anything with 4 fingers is bad. Therefore, we treat that as a malware. And now, obviously, that's not true. Anything with 4 fingers might be good. It might be bad. So the problem with heuristics is we get a lot of false positives. So whilst we're picking up detecting malware that doesn't need an exact signature, we're getting a lot of false positives. And heuristics also takes a lot of processing time, a lot of power to perform. So we often see nowadays that antivirus software will do a signature-based scan, and it will also do a heuristic scan as well to pick up what it didn't detect the first time around. And another issue that we have with antivirus software is that nowadays it has to scan so many different types of file that file parsing exploits are a real problem. So an example might be that we've got a piece of malware that is easily detectable by its signature, but if it presents itself as a different format to antivirus software, it will bypass the antivirus software. So it might be an executable file, but it's saying to the antivirus software, actually, no, I'm a JPEG. The software is going to look at different places for different signatures, and it's going to bypass our virus scanners. So these are some real problems that we've got today with signature-based detection. And for those of you at the back that can't actually read this, what I've done at the top, that is actually a quote. Traditional antivirus software is dead. That was said by a guy called Brian Dye. Now, for those of you who don't know who Brian Dye is the VP for Symantec. He's saying that antivirus software is dead. Now, hopefully you all know who Symantec are. They're one of the biggest antivirus software companies out there. For him to turn around and say that traditional antivirus software detection is dead, it means a pretty big thing. So he estimates that we're probably, through signature-based antivirus detection, we're probably picking up somewhere in the region of 40 to 50% of the malware that's out there. So that means we've still got 50 or 60% of the malware that we're not detecting with these techniques. So, yes, don't get me wrong, I'm not giving you the message to go out and uninstall your antivirus software. Please keep your antivirus software on your laptops, on your servers. You know, don't stop using it. Signature-based antivirus detection is very good where we know the malware, where we've got a copy of that malware. It will detect it, it will pick it up, it will disinfect your machine. It's just not very good for the stuff that we don't know about. So, oops. Okay, so before we talk about other techniques for detecting malware, let's talk a little bit about how botnets in particular have evolved over the years. So this diagram here is showing its time along the bottom, and it's different types of botnets that have come along as time progressed. So back in the early 90s, we started to see the first botnets coming out, and these botnets were based on IRC, Internet Relay Chat. And they would talk to each other using this protocol, and very easy to block. We'd simply block port 6667, I think it is, for IRC. And once you block that malware is not going to get onto your network. So malware authors cottoned onto this and said, well, tell you what, rather than use IRC, let's use a protocol that's a lot more difficult to block. So they use HTTP, and you can block port 80, but it's going to cause your users, people using the internet, it's going to cause them a lot of disruption. So we saw botnets move from IRC to HTTP-based malware. Botnets have also changed as networking technologies has changed as well. So the first botnets were very much centralized botnets, command and control server botnets, client server botnets. So if you remember the picture we saw earlier, we saw a bunch of botnets, a whole bunch of botnets being controlled by 1 or 2 servers. Now, the problem with that is because you've only got 1 or 2 servers, you've got single point of failure. So to take down a botnet, what you want to do is you want to go for those servers as opposed to disinfecting individual machines. So you take down a server, you're going to take down a botnet. So that we started to see multiple servers and viruses, malware, botnets, dual homed, so we take down one server, the botnet wouldn't disappear, they would simply rehome themselves to another server. The problem with that is you need to start the networking skills and the programming skills to do that. The more and more servers you get, the more and more complicated it is for these to actually design and build botnets. So in the beginning of this century, we saw botnets move from command and control client-server-based topology to decentralized. So this is peer-to-peer technology, peer-to-peer topology, where every node within a virus could be either a client or a server. So all of a sudden you've got botnets out there that are a lot more difficult to take down. The flip side of that is they're a lot more easier to infiltrate. With a peer-to-peer botnet, all you need to do is actually become part of that botnet yourself. If you can get your PC to become part of that botnet, you can then start to track some of the communication traffic between that. So whilst decentralized botnets were the next evolution and they were harder to detect, they were a lot easier to actually become part of that network. And then so just recently, we've seen the malware starting to take the best or the worst, depending on which way you look at it, the best parts of centralized and the best parts of decentralized to come up with more of a hybrid of both. So these are now becoming a lot more harder to detect and a lot more harder to infiltrate. And we've seen just within the last year, Zeus, which is one of the biggest malware, the biggest botnets out there, they actually gave their code to their nearest competitor, SpyEye, and said, we've had enough of this market now, here's our code, go away and create a super bot using our technology. So we're starting to see botnets come out now which have got hybrid techniques and using botnets are starting to come together to form massive botnets. Now, a big misconception is that command and control botnets no longer exist. They're all distributed. They're all peer-to-peer. This is a slightly old diagram, but if we were to extend this curve up to date, we would still see very much so that centralized botnets are still very much out there. They're very much alive and well. And if we were to go onto a web page like zeustracker.abuse.ch or SpyEye tracker, you'll see that we're actually finding 1, 2, or maybe even 3 different variants of Zeus still coming out on a daily basis. So these viruses, the centralized viruses, command and control based viruses, are still very, very much an attack vector that's being used today. Oh, no, we've done that one. Okay. So in order to detect botnets, we need a different technique than we've used traditional signature-based antivirus detection. So if you've got a botnet of a couple of 100,000 bots, and we've got antivirus software that's going to pick up one machine and disinfect one machine, we've still got a lot of bots out there in this botnet. So antivirus software isn't really a way of it will protect an individual against a bot, but doesn't work towards a botnet takedown. So what we need to do with botnets is, as I said earlier, we need to actually try and find the command and control center, so the command and control server, and by taking that down, we'll then destroy the botnet. So one of the weaknesses of bots is that they all talk to each other. They all talk to each other. They all talk back to the command and control center. So that might be for things like patches to keep them undetectable. It might be for Botmaster might be sending out a new script. They might be talking back to command and control center to say, I've found a whole load of logins here. Here's my latest data I'm going to upload. Or it might be the actual attack commands that the Botmaster is saying, right now we've hit a critical mass of bots. We'll all go out there and attack. So there's this constant chatter between, there's a regular chatter between bots and the command and control center. And this is what we're using now to actually detect the presence of botnets. Now, botnets are generally on the internet. They use HTTP to communicate. So that means that to communicate to their command and control server, they need to know the IP address of that server. So early botnets used to have that IP address built in. Very simple. We get a copy of the sample of the malware, reverse engineer it. We've got the IP address of the server. We take the server down from that. So modern botnets have started to look at different ways of hiding the IP address so that we can't find them. So there's companies out there that use DNS-based techniques. Because we're going from IP addresses to domain names to IP addresses, we can use DNS record analysis to actually track these botnets. And there's companies out there like FireEye, like Dembala, that are analyzing DNS records for botnet communication in the cloud. They're then working with local authorities, government authorities or ISPs to detect the botnet and then actually take down that botnet server with help from police, from ISPs, that kind of thing. So the way that we do this is by analysing DNS records, DNS record analysis. And if you look at how botnet communication differs to human communication on the internet, and there's quite distinct patterns. So if I'm a user on the internet as just me as a single node on the internet, I might connect out to google.com or bbc.co.uk or various other websites. You've got me as a single node with a few different spokes coming out. If you look at how a botnet communicates over the internet, you'll have the botnet itself will only talk back to maybe one or maybe two servers. So you've got a single node with only a couple of spokes coming out. You follow these spokes back to the server itself, then you'll see a server with a couple of 100,000 spokes coming out of it. So it's very, very different traffic profile between a human user and a botnet. So it's these different, it's not as simple as that, but it's these kind of patterns that we're looking for in detecting botnets. So botnets, the way that these companies do it is very much a big data approach where we're collecting thousands and hundreds of thousands of DNS records, looking at these DNS records and using machine learning techniques to start to look for some of these patterns, some of these signatures of bots communicating with the command and control server. So really what I'm trying to say here is we've gone from your software-based protection on a single PC, we're now moving into cloud-based techniques, looking at using the internet as a way to detect malware. So it's a very, very different approach. So as we're developing new ways to detect the malware, the bad guys out there are as quick as we're inventing a way to detect them, they're inventing ways to evade this, the way we're detecting them. So one of the ways to evade DNS record analysis is through fluxing. Now fluxing basically means to change. It means nothing more than to change. But the idea of fluxing is we're trying to, where we're using an IP address to identify the server, by fluxing we're trying to disassociate the domain name with the IP address. And there's two main techniques that we use to do that. We use IP fluxing and we use domain fluxing. So IP fluxing is where we might have a couple of thousand different IP addresses pointing back to one domain server, and the bot is rapidly cycling through those IP addresses so that we can't use DNS record analysis to actually work out which IP address is the legitimate IP address talking back to the domain name. And because we're cycling through those very rapidly, that's known as fast fluxing. The opposite of IP fluxing is domain fluxing. So here we've got a few thousand domain names that we're cycling through, going back to one IP address of a command and control server. And domain fluxing is generally the technique that's used today. Now, again, in the early days, the malware authors would put the different domain names. They'd put maybe a couple of hundred domain names actually into the code of the malware. We'd get the malware, we'd reverse engineer the malware, we'd come up with those domain names. So they needed new techniques in order to be able to do domain fluxing and create new domain names. So they use a technique called domain generation algorithm, or GGA. Now, I don't know if any of you guys, I'm sure a lot of you get spam email. I don't know if you've ever looked at the domain name on a spam email from a DGA, from an algorithm that's generated the domain name. It's very, very different to a human generated domain name. So we might use something like bbc.co.uk, whereas a DGA would generate something like $L9T! Exclamation mark, blah, 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 blah. So we're coming up with something with a very, very different entropy that's being generated by these algorithms compared to what's being generated by humans. So a very good telltale sign that we've got something suspicious going on is that the domain's got a very high entropy. It looks very, very different to a normal domain. But from a malware's point of view, DGA is perfect for them because it's very difficult to blacklist algorithmically generated domain names. Because there's so many of them and because they're so wide and varied, you can't just blacklist this and say, this is a domain I don't want you to go and talk to. There's so many of them. And the other thing is because the malware is generating hundreds of thousands of these in one go, there's probably only one command and control center set behind a whole bunch of domain names. So we don't actually know which is the real domain name to go back and trace the command and control center. So DGAs and domain fluxing tends to be the main attack vector nowadays for malware, for botnets to avoid DNS evasion. And you may have heard of Conficker, Torpig, Kraken. They're all very big botnets that have been around for the last few years. These guys all use DGA techniques to evade DNS detection. So the takeaway here really is, yes, there are ways that we can detect, different ways that we can detect botnets through traffic-based techniques, but just as we're inventing ways to detect them, the guys out there are inventing ways to evade these techniques as well. So some of the work that we're doing here at Angular Ruskin is to look at alternative ways for detecting bots. And I don't know how many of you guys have ever used Flow protocol before? Anyone know what Flow? Yeah, a few of you. Okay, doesn't surprise me that the majority of you guys haven't. Flow's a relatively new-ish protocol. It's been around for a while, but it's only really been used just recently for botnet detection. Flow is defined there in this paper here by Drago. Flow is a unidirectional stream of packets that pass through a network element. I'd actually argue that it's a bidirectional stream because you've actually got communication going in both ways. But effectively, Flow is a stream of packets that's passing through a network element. So it's a protocol for collecting and monitoring network traffic, and that's really what it's used for. So many years ago, we used to have SNMP, and Flow really has evolved from SNMP. SNMP is a polling device, so you're polling a MIB every X number of minutes, and that device is reporting back to you whether there's been a change or not. And the problem with SNMP is that there's a lot of overheads involved with SNMP, so it's not really an ideal protocol for using for botnet detection. So SNMP evolved into what we know and love now as syslog. Syslog is more of a push technology. It's pushing the information it's collected out to a syslog agent. And the problem with syslog is it's very unstructured. It's very good for logging, but it's not very good for reporting. So the clever guys at Cisco took SNMP, they took syslog, and they came up with Netflow. And Netflow is a very, very structured protocol. Because it's structured, it's ideal for reporting, and it's also ideal for looking for anomalies in network behavior. So I'm sure a lot of you have used Wireshark, and you use Wireshark to look at packets, metadata, IP address, source destination address, protocol, that kind of thing. That's what we use in Netflow. Netflow really is collecting the metadata of a stream between different devices and basically reporting back on everything that it's finding. Now, even though Netflow was developed many years ago, I say it's probably only within the last 5 years that we've been using this type of technology to detect botnets. Netflow is just one version of the Flow protocol. Netflow version 9 was standardized to become called IPFix, and it's standardized under RFC 7001. So most devices nowadays, most network devices will have a Flow exporter of some shape or form inbuilt into them, but just because we're standardized on IPFix, it doesn't necessarily mean that that's the variant of Flow that they're going to use. So we have Netflow, we have IPFix, and we also have a protocol called SFlow, which the purists amongst us might say that's not really a true Flow protocol, that's more of a sampling protocol. The way that SFlow, or the way that Netflow and IPFix work is they will gather everything that passes through the devices. The way that SFlow works as a sampling protocol is it will only collect maybe every 5th packet, or it might be set to choose randomly capture packets as it goes through an agent. The problem with that is we might miss that one important packet that we needed to detect the botnet. So, Netflow, IPFix, SFlow, they're all different variants of a protocol. And it's still very early days. We don't know which one is the best one to detect botnets. We know that Netflow works. We still need to look at IPFix and look at SFlow to see whether they're going to work as well. So, as I said, we're using things like, to actually detect the botnets themselves, we're using things like IP source address, IP destination address, the protocol itself, the port numbers. And similarly with DNS traffic, we're building up a topology of who's talking to what. And then we're using machine algorithms to try and work out is this a legitimate network traffic? Is it botnet traffic? Is it malicious traffic? So we're using similar techniques. This is a traffic-based detection technique, so it's very, very similar to DNS. And some of the more important academic work nowadays is actually trying to work out what is in this masses and masses of data that we're collecting. If flow has a drawback, the drawback is it collects too much data. It's collecting data for every single conversation on the network. So if you've got two PCs, 192.168.10.1 talking to 10.2, it's going to capture a stream going both ways, so two streams for every single protocol. Now, if you're running a Windows network, there's going to start capturing quite a few protocols. So if you're going to upscale this to many, many thousands of machines, you're going to have tens, hundreds of thousands of flow streams that you need to capture and then need to analyze. So some of the clever work is being done in the correlation or clustering of what look like might be botnet signatures and actually trying to take away some of that noise of what isn't botnet signatures. So there's some important pieces of work such as a paper called Bot Cloud, a paper called Bot Hunter, a paper called Disclosure, a paper called Fresco, and all these papers are saying, yes, flow techniques are a very good way to detect botnets, but what about all this noise we've got? What are the correlation techniques that we need to use to get rid of some of this noise and actually come up with some real signals of botnet? So correlation techniques tend to be split into two different types of technique. You have vertical correlation, which is looking at looking more for bot-related activity, domain names, outbound scans, that kind of thing. Then you have horizontal correlation, which is more looking at network events and saying, is this network event anomalous? Could it be caused by a botnet? Now, it's because horizontal correlation is looking at network events, it's not such a good way for detecting botnets. Actually, what we want to do is use vertical correlation methods to actually see real botnet traffic, real botnet events going on. So this is where a lot of the exciting cutting-edge work is being done into developing different correlation techniques. And some of the algorithms that are being used are similar to things like Google's PageRank, where Google will suggest a page for you on the internet depending on the number of clicks that other people have gone to. PageRank algorithms are being used to try and determine what of this traffic should we actually look at. What do we think is botnet traffic and what isn't botnet traffic? Okay, so So this is some of the work that I'm involved in here at Anglia Ruskin. I'm looking specifically at trying to use flow types protocols to detect botnets in a specific environment. I'm looking at detecting these guys in virtual environments. And why virtual environments? Well, there's a whole bunch of reasons. Virtual environments are the ideal breeding ground for botnets. If I can take a virtual machine, infect that machine, and then clone it again and again and again and again and again, very simply, very quickly, very easily, I've got a reasonable sized botnet in a few minutes. So not only are they the ideal breeding ground for botnets, but virtualization now is an established technology in computer networking. I'm sure most of you guys out here are well aware of virtualized technologies. Most businesses, most corporate organizations will have a virtualized network of some sort. Cloud providers will also provide their services based on virtualized technology. So virtualization really, for me, is probably the building block of the next generation of the internet. The Internet of Things, smart cities, that kind of thing, all these will have some sort of virtualization involved in them somewhere. And there's not a lot of work being done in detecting botnets in virtualization. We focus our efforts on detecting them on networks, on individual machines, or in the cloud, but not a lot of work has been done on detecting them in virtual environments. And so this is one of the areas that we're looking at here in Anglia Ruskin. I think that one of the reasons that we sort of ignored the virtual environment for botnets is there's been a misconception that botnets are virtual aware. They're aware of virtual environments. And because a malware researcher will put a botnet into a virtual machine to study it and dissect it, there's a misconception that maybe as much as 80 or 90% of botnets know they're in a VM, therefore they'll either change their behavior to act like a normal piece of software, or they might delete themselves so the researcher can't study them. So there's a piece of work done a couple of years ago by two guys called Lau and Sveja back in 2010 that actually took most of a big sample of malware to try and find out which of this malware was VM aware. Now, our preconceptions were at the high 80s, maybe low 90s malware. They actually found that only 2% of malware was actually VM aware. It would detect itself in a malware and in a virtual environment and change its behavior. So this preconception of malware being VM aware is really a bit of it is a myth. It's a misconception. And I think to prove this, back in 2012, we saw the Crisis virus. Now, Crisis was a virus that jumped from the host operating machine. It was a botnet that jumped from the host operating machine into a virtual machine. So it was able to, the first virus, to make that jump, and it actively looked for VMware-based virtual environments in order to propagate it. So this was 2 years ago. We're starting to see the first viruses now to actually physically attack virtual environments. So the fact that there's not a lot of work being done in this area, and we're starting to see, this is an unexplored attack vector for malware authors. I think over the next few years, we'll start to see more and more viruses being targeted at virtual environments. So this is the area that we've decided to focus our studies on. And just to kind of tell you what we've done so far, very briefly, we've managed to, within a virtual environment, we've managed to put Zeus into a virtual machine, and we've managed to get Zeus to clone itself across different virtual machines. We've managed to detect that using flow traffic, detect those signatures against the background noise, and we've been able to trace back, using those signatures, trace back to the actual VM, which is housing the command and control server. And by taking that VM down, we've done what we've tried to do. We've now eradicated that botnet from a virtual environment. So it's still early days. There's still a lot of work to do, but it's work that's definitely starting to show some good results. And I don't know if Razvan's in the audience. I can't see Razvan. This is just part of many projects that we've got on at Anglia Ruskin using flow techniques for botnet detection. This afternoon at 4 o'clock, my colleague Razvan is going to be doing a talk on using Netflow and IPFix to look at VM placement and detect botnets within VM placement. So this is part of a multiple stream project that we're doing here at Anglia Ruskin University. Okay, so just to finish off, hopefully what I've managed to do today is talk you through some of the weaknesses, some of the drawbacks of signature-based antivirus techniques. As I said earlier, it is still a technique that we can use if we know the virus. Please don't go out and say, Mark said uninstall our antivirus. That is not the message Mark gave us. It is still a very much used and tested, very much a useful technique today. But there are other techniques out there. There's these traffic-based, anomaly-based, signature-less detection techniques that we can use. And hopefully we've seen that malware detection has now moved away from individual PCs, protecting individual PCs. It's now moved into becoming more reliant on ISPs and cloud-based technology to detect the malware. So I think for me that opens up quite an interesting question or interesting conversation is, whose responsibility is it to protect us against these things? Is it our own responsibility? Should we be putting antivirus software on our PCs? Or should we now be saying, well, hang on a minute, this doesn't work anymore. We now need the ISPs of this world to actually protect us against this. And I think maybe the answer is both of those. I don't know what the answer is. I'm not here to debate the ethics of that. I'm here to try and discover some tools to do that. But I think over the next few years, we'll see some interesting changes in who is actually responsible for detecting and protecting us from malware. Thank you. Anyone have any questions?
Do you have any idea of how long it takes to actually do this flow analysis? So if you've got a small set of botnets, how long do you take to detect it?
Okay, so the question was, how long, if we're doing flow analysis, how long is it going to take us to detect botnets? Because we're using, because it's a big database technique, we're actually trying to do this in real time. So it's not a kind of a post-infection scanning technique that we'll do in the background. We're looking at real-time analysis. Certainly for DNS evasion techniques, I mentioned 2 organizations, Dambala and FireEye. There's a whole bunch of them out there. These guys they're doing this in real time. This is real-time analysis of data. And this is one of the problems that we've got. Because there is so much flow data, we need to get rid of a huge majority of that and actually focus on what we need to look at. So the goal is to be doing this in real time. But the goal is also to make sure that we've got enough useful data that we can throw away the rest that we don't want, but use that data to actually detect the command and control server. I think, Dave, did you have another question? Or? Okay.
Hello? Hello? Okay, it's not really. Hi? Okay. It works? Okay. So I think you spent like most of the slide giving introduction on what is a botnet, how a botnet works, different method to detect botnet. And then you had one slide where you basically introduced what you've done. So my question is, because you suggest that there is a follow-up talk this afternoon from your colleague at 4:45. Yeah. So is your colleague going to describe better what you did? Okay. Because so you didn't have time basically to. Okay. So the question is, I spent most of my talk talking about different techniques, different detection techniques, and a little bit talking about what we're doing here at Angular Ruskin. That was intentional for a few reasons. One is I wanted to try and give more of an education about the different techniques for botnet detection. The other reason is I am studying this. This is my PhD focus area. I've only really been studying this for a few months now. I'm 4 3/4 months into this, still counting it in days. So this is still very, very early work for me. So it's still work that I'm very much in the learning curve and starting to do. So and the other thing is some of the other work that we're doing I haven't published yet. So I can't tell you we're doing this, this, and this. And then you guys say, oh, I've got an idea, I'll go and publish it. So there's a number of reasons why I haven't done that. So you're right. My colleague this afternoon is going to do a talk. Razvan's coming towards the end of his PhD. He's been doing this for 2.5 years now. So he's been looking at slightly different areas. I say it's more to do with VM placements as opposed to actually detecting. It's detecting malware already within VMs as we're cloning them and placing them within network. So it's a slightly different branch of what I'm doing. So I don't know if that answers your question or not, but yeah, for me it's still very early days. Just a follow-up question. So if I understood correctly, what you do like Netflow correlation on data that are captured from the VM. So basically you have a VM with different VM running. Yeah. Yeah. And then you basically capture the traffic at switch level, or I don't know where. Okay, so that's one of the things that we're trying to answer is. No, just a question. So my question is, what is the difference between having your setup and a setup where there are no VM? Suppose you have like a machine in a network, some machines are infected, and you collect the traffic at gateway. Okay. Yeah. What is the difference between that and the VM? So what makes special having the detection at VM level? Okay, so I think the question is, what's the difference between doing what I'm doing in a VM and doing this on a normal network? Yes. Yeah, okay, so there's a paper come out earlier this year that has done similar to what I've done on a network. But this was on a simulated network. It was on a GNS3 network on a sort of a Cisco LAN, if you like. There probably is, I'm going to say there's no difference to the techniques that we're using here between to try to detect it in a VM versus compared to a network. But I think the issues that we've got is, or the questions that we've got is, where do we site these samplers? We could site them on a VM itself. We could put it on the switch. We could put it on a virtual router. We could put it on maybe on the hypervisor. There's a whole different bunch of areas where we could site our network flow probes, and we don't know where the best place to plant these is yet. So there's a little bit of work needs to be done to determine where the best place is. And I think when we're looking at malware in a virtual environment, it has another advantage in that malware in a VE can hide itself, like rootkits do, they can hide itself underneath the operating system. So the operating system will hide itself in the kernel so that the applications aren't seeing the malware signature to detect them. So what we're looking at is it best placed to have a detection system within a virtual machine,
or should it be actually outside of the virtual machine within the virtual environment? So I think we're looking at using the same techniques to answer slightly different problems. So to answer your question, what is the difference between doing this and doing this on a normal network? There probably isn't. We're using the same flow technology, we're looking at the same flow protocols, the same flow parameters, so it's a very, very similar technique, but I think we're trying to address slightly different areas. Does that answer your question? Yeah? How are we doing for time? Have we got? Yeah? Okay, so I think we've got time for one more question. Yeah.
Hi.
I'm around for a few days, so yeah, but yeah, I'm here for 2 days, guys, so please do come and talk to me. I'm very interested to talk to you guys about the work I'm doing.
Thanks for the presentation, really great. Just wondering, with the large amount of Netflow data you're collecting for vertical correlation, have you explored the possibilities of using some cloud services like Amazon's Redshift for computing and analysis of this data?
Yeah, absolutely. So the question is, we're collecting a whole load of flow data. Can we outsource some of this to some of these sort of big data-based analysis companies that can do some of this analysis for us? Yeah, there are a lot of these companies out there. And I think, personally, I'm too early in my research to actually decide that I need to do that. But I think it is something that we need to consider, because we've got so much information. There are organizations out there that specialize in doing this, searching through big data quantities of information and machine learning techniques. And I think that's as I tried to say, flow has almost been established now as, yes, it is a tool we can use. What we haven't been able to do is come up with the right algorithms. I mean, there's so many different papers. There's maybe 20, 30, 40 different papers out there that talk about the different correlation, different clustering algorithms. And I think that is an area that still needs a lot of work to be done. And like you say, maybe outsourcing some of this to rather than using one PC, to shift it out to the cloud where there's a load of processing power to do this. Yeah, absolutely. I think it's definitely an opportunity. Yeah. Okay, is that? Yeah. Okay. Thank you very much, guys. I say. Thank you. I'm here for 2 days, so please
So my name is Paolo, and I'm just presenting a small project that I've been working on the sideline. And the idea is essentially to monitor websites for malware injection. And the name of the project is WebDetector. I might change the name, so it's not that important. So, I'm not a pen tester or like a security, kind of traditional security analyst, but I did most of my work. It was in the early days of, pre-Windows era. I was working a lot of on doing keygens, mostly illegal stuff, but it was from a security, like it was from a study point of view, so like to see, how much vulnerable was software. And probably, well, like at the time I was working on basically the first bytecode patcher for Java Mobile, and at the time there were a lot of wares running on Java phones. That was quite fun. But my research is mainly on machine learning and social robotics, which has nothing to do with security, of course. So I recently, I did some work on with previous companies in security, just purely from a research point of view, and I'm currently working for Microsoft, which is a little bit, it's a little strange. I've always been a Linux user, so, but it's quite interesting on the research side. Like, there is this kind of perception of Microsoft as a kind of very conservative company, but internally there is a lot of research. And so I'm focusing on machine learning applied to intrusion detection and big data and security. And I was quite intrigued by Microsoft. They allow me to carry my own research project. So, and this project in particular is based on open source tools. And yeah, everybody is happy that like somebody's working on like not Microsoft technology inside, and maybe one day there will be an exchange between closed door open software. So it's quite interesting the way Microsoft works. So the problem is that what do we want to solve is like ask yourself how many websites are compromised, lots of them, and what are the most common attack vectors, and how can we monitor a website? And say, like for a website that just mean anything like very simple stuff, like if you have if you're a small company, you have some blogs, you have like your front-facing corporate website, you have maybe an e-commerce cart, like very, like wide variety of like website, just that you expose to your customers onto the web. So, yeah, you can buy these expensive solutions from different companies, to do application layer security and that kind of stuff. But I wanted to have something very simple, so I wanted to have something that, like a common user, a common IT web admin can install on his computer and say, oh, let's see, like, every month I want to crawl my own website, and if there is something different, like there was a new page added, there were new links, new modules, I want to know if that's me, like updating the website, or like it was an update for WordPress, or it was actually somebody was injecting some JS, there was some cross-site scripting that I'm not aware of. And some of the time, like most of the times, I mean, depends on the attacker, like you might get, it might not something be so evident. So you might be something polluting your like web directories with malware, like that is used for spamming, so for distributing malware and that kind of stuff. So it's not that easy, to actually see, okay, I'm browsing my own website, oh, that's something strange. So so that was the idea, like very basic detection of changes in your website, and look for like very basic attacks. I'm not doing any kind of sophisticated analysis on the on a website. So we have three components. So one, we need to know, like, we need to have a way to monitor changes in your website. We need to have some sort of JS sandboxing environment, so to kind of emulate your scripts, without the risk of getting infected yourself, and some basic heuristics to detect these kind of attack vectors. This was a report from Whitehead in 2013. I didn't do the 2014 because I didn't want to pay for for the money, but you can buy. I think they can tell you how much money was that. But you know, it's I don't know how they actually measured like this percentage, these numbers. But yeah, they were quite interesting. So they were saying the big picture is like 86% of all websites were compromised with an increase of 4% from the last year. And there were like 56 of these websites that serious vulnerabilities. Yeah, just some interesting numbers. And obviously, the most common vulnerability now is XSS. I remember in the past was SQL injection, but now it's kind of become more popular. I think because JavaScript is taking over, so there is a lot of dynamic web development going on. Interesting things like education, healthcare, and insurance are the one with the slower fix. So healthcare has a 226 days of average fix. That's quite a lot. But yeah, surprisingly, in government, it's quite fast. So like on average, they have 48 delays in fixing things. And entertainment media, which probably is where all the profit is, they're quite fast. 33. Gaming, surprisingly, is like 67 days. So it kind of varies, but yeah, the bigger idea is like, well, we have a lot of vulnerable websites, and we want to find a way to kind of monitor them, especially for XSS. So that's a kind of distribution. I mean, again, it's a report from, this was like 2011, so you can download it, you don't have to pay for that. And yeah, as I said, 50% it's cross-site scripting, 14% it's content spoofing. I think there's a typo there, it's not my typo. And intrusion leakage and SQL injection went down to 4%, which is quite interesting. There are like 3 types of cross-site scripting. I'm not here to lecture you about, you probably know about this. So it's store, reflecting, and DOM-based. There are several vectors. So there is GIS, PDF, so Adobe PDF, ActiveX, iframe, and Shockwave. And for the purpose of monitoring, the only way that I have to detect XSS is for storage side cross-site scripting, because we are not. So the idea is I'm not actively probing your website to find like vulnerable point of injection. I'm just basically looking at your HTML pages and see, somebody might have done some sort of cross-site scripting. And the only way I have to do that, I can do that, is because it was stored on your server and then it's just played back on my browser. And when I pass the page, I'm able to find like strange things. And there are like basic behaviors that you can detect. Again, nothing really complicated. So I can find, it's quite obvious if there was an URL injection to a malware dropper. If there was a form injection for phishing, page redirection, and cookie stealing, or like, yeah, any form of cookie manipulation is kind of suspicious. So the very first version of my kind of tool was very basic. So I was using basically wget with some sort of Python script. No, it was like bash scripting. So I was getting a mirror your website. I was applying Git on top of that, so I could see the changes. It's basically your source code is your is your web page resources, and I was getting Git on top of that. So every new pool of your website, there was a Git commit, so I can actually see what was changed and what was not changed. And then on these diffs, I was applying this heuristic to say, there's a new IP is pointing outside, or there is a new strange obfuscated JavaScript code running on this new page that looks very suspicious. The problems were that the wget, okay, it's a very nice tool, very fast. It's available on every Linux box, but it's not that good at crawling, especially for dynamic pages. So I was crawling, like WordPress sites, and there were so many pages that I couldn't fetch because it was like all dynamic content. So when wget was running, it wasn't sending post requests to request that page, and it was like I was getting basically like say 10% of the entire website was missing. Really, 90% of pages were not being crawled properly. So what do we want to know? We want to know what was added, what was removed from the website, when did that happen. So it's really important because if there was an admin was doing some updates, then we know that, oh, that day, the admin was adding a new page. So that's probably what it was, That's essentially to reduce false positive. Who did it? Okay, that's a little bit more complicated. So it's hard to say. And then essentially, like, is it malicious behavior, or is like some sort of new library that was added and was obfuscated or was like minified? So we don't want to kind of flag that continuously to reduce the false positives. So the architecture is quite simple. You basically give, so you have a job queue. You get all your URLs or domains that you want to monitor. It goes into Eritrix, which is a web crawler. Eritrix produce a sort of compressed mirror of your website. They have an ingester that takes this kind of output. So you have two file formats with WARC, or the old one is ARC. The ingesters kind of index the entire thing in a MySQL database. It can be any other database. I just use that because, I was familiar with the MySQL. So for each resource, you get an index, you get timestamps, you get a fingerprint, like an hash for each new resource. And then from there, I start to do a little bit of profiling. So I want to know, so for each page, I want to see the JavaScript, what kind of JavaScript was running on that page. If the JavaScript was manipulating the DOM, which is the kind of structure of your XML or your HTML page, I run another analysis to see how the DOM was used, if it was doing something tricky. And to do that, there is a tool called tag. And after that, so after these kind of 3 steps, I produce a report. Unfortunately, nothing really visual at the moment, so it's like just very basic CSV files that you can open. And I also store everything on a MongoDB because it's flexible, so you can add, it's schema-less, so you can add new attributes as you do your crawling. If you have new features to put in your database, you can easily add those kind of things. So does everybody knows what Mongo is, or Eritrix, or how many people did use Eritrix before? Oh gosh. Okay. And right.
Eritrix is your web crawler, so you can
yes.
go to the website.
Yes.
Quick question. I'm sorry, this is premature,
Sure.
but Thug, is that then going essentially an Ajax crawler, so that you can go?
Yeah, I can show you later. So there are a number of technologies I use. So everything sits on a virtual box. There are 2 reasons why I want to have something that was easy to deploy and destroy. And then the security, obviously, if you're crawling things and there is malware, you don't want your own box polluted with some sort of malware. So you don't want that. So if you think about layers, so there's VirtualBox is the kind of execution environment. Then you have Vagrant. I don't know how many people did use Vagrant before. I'm just curious. Oh, there are people know about Vagrant. So Vagrant is essentially a set of tools to kind of make your job easier when you set up a VirtualBox. So if you think about you installing a new image, say an Ubuntu, an Ubuntu environment, so you have to install that on your VirtualBox. You need to install your tools. So you need to do that kind of manually, and it takes so much time. But Vagrant allows you to make everything automatic. So you build a set of scripts. It can be, well, to make it, you build a script and you say, okay, I want to deploy this particular version of Ubuntu, and I want to install, say, Java, Python, Perl, all the software that you need on that machine. It will set up for you all the nutting, so like all the port forwarding. It will create an SSH configuration so you can log into the box. It's just like a way to make it, to deploy a box and install everything you want on that one. So main technologies is Python, Java, and V8 for Google, and you will see why. And then obviously there is Tor, so like I use Tor for anonymization, because when you do these kind of crawling jobs, there are some, most of the malware sits on, unfortunately, pornographic websites, so you don't, you don't want to be. I had some interesting situations when I forgot to turn on Tor, and your admin will not be very happy. So now you are crawling an entire porn website. Like, what's that for? Yeah, for research, yeah. So Elytrix, it's quite interesting. Not so many people know about this, but it's the only project, well, it's one of the main tools that the W3C organization have used to crawl the web. So if you go on, I think it's called the Historical Web Database of the Internet, they use this Elytrix software to pull, so they essentially crawl important websites. And you can see them back in time. So you can see, okay, let's see how Facebook looked like in 2000 or something like that. So they don't have all website. I don't know if it's what kind of political correct version is to define what an important website is. But they have like fairly a good amount of big websites, and they crawl them with this software. So it's well developed. So the last version was in January 2014. So it's well maintained. There are auto plugins. It's a very good, efficient crawler. You can distribute it on several machines, so you don't have to run it on just one machine. It's Java-based for a number of reasons. But yeah, it's quite good. I mean, it did the job for me, so I don't know if you know any other kind of good crawlers. And then one of the other components is Python tag, which is kind of a low interactive client for browsing pages. Again, it's well developed. The last version is March 2014. Sometimes I do some patches, so I contribute to this project. So it's still kind of work in progress. But it currently detects around 161 exploits, and including Adobe, Shockwave, and Java Web exploits. So it's quite good. It uses kind of a mix of a signature and a more like behavioral-based approach. So it kind of builds an abstract syntax tree for each exploit. So even if the exploit changes, it tries to do this kind of trying to do a little bit of littering of code. It's still kind of it's still kind of resilient to like polymorphic code. But yeah, it's a work in progress, so you don't expect too much. So the other component, which is quite interesting, is it's a patched JavaScript monkey, which is the interpreter that's used by the Mozilla organization. So you can, you have the source code, so you can recompile the JavaScript, and you can add you can hook particular functions. And then, so from a security perspective, I was very interested to know, given a JavaScript source or file, I wanted to know how many document write were executed on that particular code, how many string instances they were created, how many element instances were created, how many object instances, how many evals, and that's probably you know why. How many location operations were done? Location is like host, host name, href, origin port. How many escape and unescape they were executed? How many encode? So encode URI, decode URI, and how many decodes from the component perspective. So the only things I didn't put yet is the cookie, because that's quite important. Yeah, I didn't do that yet. So it's kind of presented some old results. And the nice thing, if you have an encrypted or an obfuscated component, this is fairly easy. I couldn't put anything on a slide that was complicated, so I just put some very basic. But if you have an obfuscated JavaScript code like this, I can get anything because I'm at the interpreter level. I can get the the output, just the obfuscated. So this one was doing. Oh yeah, this one was doing some exfiltration. So it was trying to basically get the referrer from the chronicle page and send it to another website. And then, so as you can see, in this case, there were 4 string instances. There was a document write. There were 2 evals, and there were no operations on the object side. So version 3 of WebDetector, I'm planning, if I have time, to do a Django app. So So currently everything is kind of console based, so you need to type everything from the command line. So it's not very user friendly. But the idea is that we'll put a web interface where you can create your job tasks and you can put new rules like, oh, I want to detect this specific threat or something like that. There are other tools that can do a better job to analyze JavaScript. There is Dodzo, it was developed by Microsoft. But yeah, I want to make it more as extensible as possible. And for anonymization, so like in my experience, I was setting Tor on my own machine, but some of the time you might forgot to run that. So like happens. So my personal experience, I like to say I was using a Raspberry Pi with Onion Pi. So I was actually sure that if I was on that particular Wi-Fi access point, then it was encrypted. So in that way, you can't, you don't forget that maybe you are not, you're anonymized or not. So, just my personal experience, so maybe if you're more careful, you probably remember to turn it off and Tor again. So this is more like the kind of pipeline I do. So you take from the URL, you do the crawl, you ingest all the resources, you index it, you do analysis. So I start from the HTML, I extract all the components. So I get the JavaScript. If it doesn't contain DOM manipulations, I run it through the monkey patch, so I can do that kind of profiling. If it contains the JavaScript, DOM manipulation, I pass it to the Python tag, which is this kind of low client interactive, and then I produce a report. And this is like an interesting thing. Okay, so there were like 13 websites. You can see for each website there are like the distributions for each of these 6 function calls for JavaScript. And I just a question for you, like, can you find, how can I phrase this? Can you find like for this particular bar chart, can you find or do you think which websites are malicious and which one are not?
5 through 13 are malicious.
Okay. Yes, okay. So there are 2 groups of, you can see there are 2 groups roughly because you can see, right, okay. But yeah, anybody else has another idea? There are 2 groups, yeah, so, but yeah. Anybody? Okay. You almost got there, except for the fact that it's the opposite, so. But yeah, no, you got the 2 groups. But yeah, so the first 4 websites were, I can't put the real names, but they were like, they were distributing a lot, so they were full of malware, and especially JavaScript and stuff like that. And then those are the other ones that were the good ones. So there was MySpace. I don't know if anybody used MySpace anymore, but yeah, it's still online. There was HillaryClinton.com, which is a real website. I thought it was like fake, but it's really the website of Hillary Clinton. I think I was getting some porn website. I don't know when I was Googling, but yeah, the .com is the legit one, so it's safe for browsing. Some Yahoo, what's a Fright catalog? YouTube and Photofile.Russia. It's a legit website, so it's not about porn. So the interesting thing for the kind of malicious ones, you can see. Well, that's kind of intuitive, right? The object instance profile, it's much higher compared to a good one. So if you see the ratio between the element instance and the object instance for a good one, it's almost 10%. But if you go for a malicious one, you have obviously a large number of object instances compared to the element instance. And also, like string instances are much higher. And it's probably because, if you see this kind of, kind of malicious JavaScript, they try to do a lot of, they take a string, it's encrypted, they kind of reverse the string, and then they try to execute code. So that's probably my explanation for that. So there is a lot of much more proportion of string instance manipulations compared to a good one. I was expecting more document writes from the malicious ones, but there were few. So, because sometimes, they can create some, like they create, I don't know, click jacking thing, but probably it's not that much compared to what legit websites do when they create new doc. Maybe you have a div, creating new divs, deleting new divs. So it's probably that's what it is. But yeah, so that's just an interesting profile to look at. And evals were higher. Well, evals, you can't really see the difference. It's kind of spread, so you get even good website using small number of evals. I think there was the escape. Escape was interesting. So like good website, a lot of escapes, and bad ones, they don't have so many escapes. So that was kind of counterintuitive.
That's the surprising part. You would think
Yes.
it'd be the opposite.
Yeah. But yeah, it was. I don't know if it's just because this particular data set. So your
average developer actually codes less securely than your average malware scientist, right?
yes, that's probably true. That's probably true. So because I'm a machine learning expert, I said, oh, let's apply a very simple classification. So I used naive bias or decision tree. In this case, it just gives you 100% accuracy. Well, it was a small data set, so I had like 85 good websites and 64 bad. So this is like bad machine learning, right? So it's kind of overfitting, right? You say, oh, I have 100% accuracy, but my data set is very small. But just to give you an idea, so you can see that you can kind of say what is a good one and what's a bad one. So you can kind of measure these 6 features, and you can say, oh, if if the features are in that particular range, then it's a good website. Otherwise, it's a bad website. But you can train your classifier as you gather more data. This is like Eritrix. So after you have done your crawling job, it will give you kind of a summary of all your content on your web pages. So like it will say how many, like a percentage of MIME types. So in terms of resources, how many HTTP errors you get, the response codes. So you can use that as a, you can find interesting things there. But so just to give you an idea, this is like a kind of a report you get out from the system. So we'll name, so we'll give you all these numbers, like things that were found, and then it will basically tell you, oh, this is good, and there were 2 bad ones. So just for a quick overview, so if you have like say 10 websites and you want to do it quickly, so you can just tell me about the risk for each website. This is like Python tag, so the output is quite simple. So I think it's based on meter report structure. It will just tell you, okay, what was this? I kind of, the URL was a French website, and there was this exploit, which was server console overflow. It will tell you the CVE number, when it was found, and on which page was found. So you can consider that as a signature of potential attack. This is some real data. I was running, so I decided, oh, let's see what do I find on my own WordPress website, which wasn't updated very often, I have to say. So if you go there, it's at your own risk. It's just a standard website sort of thing. So, I didn't find anything, like, looks clean. I run my updates maybe every month or something like that. But then it was, just for curiosity. And there was something like 14 of was it March or something like that. there was a drop. I think it was like so you can see there was an IP which was in numerical format, and that's kind of very suspicious. P2P, and then there was something like a PDF, right? And then obviously the PDF was containing an exploit inside. And yeah, I picked it up. It was removed at the time because there was a 403, but it was there for, I don't know, for how many days, because that was my first crawling of my website. And it tells me the page where it was found and when in the kind of destination of the URI. There were interesting outgoing links. So like, oh, there was bitdiabetes.us. And that was on a subfolder on my kind of Android thing. And unfortunately, as I said, it was already there when I was crawling. So, I didn't know when exactly that happened just because it was crawling later. So I discovered that so I was thinking maybe some sort of advertise, diabetes is a good cause. But yeah, it was full of stuff. It was just like a hijacked domain, and we were putting lots of things. And then this was not on my website. It was just crawling somebody else's website. And there was a form redirection. So you can see there was a customer that was quite bad. So there was like .com something customers, submit PHP, and it was going to somewhere else. So somebody had managed to inject some, XSS, and it was manipulating the DOM to submit the form somewhere else. So that was quite good. I mean, very basic detection, but I was able to pick that up, so I was quite happy. That was my website. So it was, I was browsing that, and actually I couldn't see, but the spam link was here, so it was like bit diabetes. And then the malware was somewhere. The malware link to download the thing was somewhere on the left side. And I was trying to do some investigation, but what happened was, essentially there was a plugin, a WordPress. It was hosted on GitHub. The attacker managed to push some code that was adding this kind of, somehow cross-site scripting. So it was a JavaScript that was generating these links. But yeah, I mean, I'm not a pen tester or anything. So I wasn't. I mean, I kind of say, oh, okay, it's interesting, but I didn't really go to investigate. So the system is kind of Git-like. So you can see, from a particular resource, this was bitdiabetes.us, it was kind of took down. But you can see like previous versions, so you can see, let me see how the page looked like during the first scroll. So you can actually see on your website how what happened to that particular page to see for like something that was added or something that was removed. So you can see the dates, you can click on those dates, and it will show you how the page looked like on different dates. So after analyzing all these kind of things, you get a report. So it measures how many exploits were detected, all the kind of profiling information. So for each website, I just made a score that goes from low to high, and then you will say, oh, so this website is a high risk of being compromised, and then you can decide if you want to investigate or not. So everything is in CSV format. Okay, since I'm going to close up very soon, things that I've learned again, yeah, AppSecEU is much better than like standard wget. You get plenty of rules, and so like if you're crawling something, and you want to know, okay, I'm not interested in images, so you can filter down particular resources. You can avoid all these tricks. So where, if you have a malicious website, they will try to do this kind of they will try to basically nest you in an infinite loop of pages, so you just scroll on that page forever. So AppSecEU have all these kind of heuristics to not being fooled by this kind of tricks. So it crawls very well. You can add plugins, so you can add things to save your resources in a different database and stuff like that. So I was a little bit disappointed by Tor because it only uses socks. And so you always need to set up a proxy on the host. I thought, it would be better if it was something that was using like on the same machine that was like a proxy directory, but I don't know why they didn't provide like an architectural decision from them. And there was something about DNS leaking, so you need to be very careful when you configure Tor by default, it won't prevent DNS leaking, so you need to be careful about that. Yeah, doing passively, there are so many things. So there was an interesting thing that I was thinking about. So how do you actually know that a web page, so how do you know that the original behavior of that page was good or bad? Because when I parse these things, okay, I see JavaScript, but it's really hard to tell if it was something legit or not. So there are simple things you can say. Okay, so if you see like an image that has a very long onload function, JavaScript function, you can kind of get these rules, but it's really hard to say. I mean, except for like a very simple, cross-site scripting behaviors, it's really hard to say what kind of was the intended behavior of that page. So I'm still thinking about how to do that efficiently. Okay, so AppSecEU equals a Java environment. There are plenty of rules and plugins you can use. There are things that I didn't do yet, so it's like check for cookie manipulation. And then check cross-site scripting also on other events like onload, on mouse over, image sources, and other things. I think there is a list in OWASP, there's a list of kind of common XSS manipulations that if I have time, we'll put in the system so I can detect those. So the next version will be on Django, a Django app with this kind of with a graphical interface. Currently, that's an annoying thing is Elytrix 3 have this kind of compressed format, which is called WARC. So at the moment, it's kind of a little bit annoying. So I take this kind of dump of the website, and then I create kind of an indexed function version of that on a database. You can do it directly. So if you write a plugin for Elytrix that will spit out the resources directly to a database, will be better. So you don't have this kind of intermediate representation, so which might be not very good for consistency. So there are a number of things I want to improve, and maybe an API RESTful interface for automation. So you can actually, if you're sitting on another machine, you can just write a request and say, oh, I want to crawl this. Like every 2 days, so you can kind of do everything kind of in a semi-automated fashion. Maybe add some sort of malware blacklist for IP. Extend these tag plugins so you can detect more stuff. Maybe plugins for this kind of more advanced JavaScript analysis. So Zozo is like, so we have 3 technologies. One is for heap overflow, Stack Overflow, and we get another one for generic exploitation of JavaScript structures. But it's kind of proprietary, so I don't know if they will allow me to do that. It's just some ideas. How many minutes? Is it done? Yeah.
Just about out of time, sir.
Okay. Good. So the project will be on GitHub at some point when I get proper stable build. The Vagrant image will be on the cloud, so you can kind of download it directly. And yeah, if you want to contact me, you can just send me an email. And yeah, I mean, if you have any other ideas that can complement what I'm doing, would be quite nice. Or questions. Okay.
Paolo, I love the presentation.
Okay.
So, but after all this build-up,
Yes.
it's not yet open source, right? So we have to wait. Any idea how long that might be?
Well, yeah. I mean, every tool that I use is open source, and I mean, I can push it today if I want to GitHub. It's just I want to make the Vagrant script better, because right now it's kind of semi-manual, so you need to. So I mean, it's open source. There is no problem to publish. It's just I need to take some time. Yeah, I will probably, like contact OWASP once it's online. But yeah.
Quick question. So Heretics,
yes.
the crawler that you're using.
Yes.
You said that it works as opposed to wget on dynamic sites.
Yes.
Right.
Yes.
Well, what if I have a site that makes a request back, grabs some JSON data, populates, puts links? Because what do you do in those situations? Have you considered using, for example, a headless browser, so that it would actually execute the JavaScript, go grab links, and then you would be able to crawl through that?
Yeah. So Python tag does that.
Oh, tug does do that.
Yeah, so it kind of simulates clicks as well, so you can see, let's simulate the guy clicking on.
I wasn't sure, it said like honeypot, so I wasn't sure.
Yeah, I kind of do intermediate now, so I start from the base website, and then I say, okay, let's start from the home page. Let's scroll like 5 levels with Python tag. But the problem is, then it gets slower. So I wanted to have a compromise between kind of fast and slow. And usually, if the people put malware, it's usually between the first levels of your website. But yeah, it's something that I'm kind of thinking about, like how to compromise between speed and crawling. Yeah, it was a good question. Okay.
Have you tried your tool or your profiler on a legitimate site which, for some kind of reason, are using JavaScript obfuscation, but not plain?
Yes. Okay, I can detect minified versions, so that's quite easy. There are some, I can't remember. So there are some obfuscation kind of tools that look, can't remember the name of the company, but there are some, the one that are like one very professional obfuscation tools that you have to pay for that usually. Those are, they look very malicious because most of the things they do, it's, yeah, to be honest, it's not nice JavaScript. But it's kind of the boundary, like what do you define kind of normal behavior or not. Yeah, in those cases, it's less accurate. So it might give you some false positives. Yeah, because so that's what I was thinking. Like, so once you get the obfuscated version, then you want to do this kind of behavioral analysis. That's another kind of second layer of analysis. But yeah, it's a good question. It's true. It's harder. No, okay. Is it okay? Sorry. Yeah.
Have you found or don't know whether this is in your scope sites which are hosting Viagra or Cialis advertisements, compromised sites?
So you're asking if okay.
Only available normally not through the site. I mean, you can't get them via crawling. Normally they are referred by search engines. If you search on Google site site name and then Viagra or Cialis, you find the sites, thousands of it, but not on the site itself.
Yes. Okay. So the question is, can I find this kind of Viagra advertised website from which are only indexed by Google by doing a search? So the way I did it for bad website, I was just so there are two things. Some websites they don't allow you, they don't crawl properly if they discover that the origin referrer was not from Google. So and because they want to avoid people kind of crawling and say, oh, that's something suspicious. So they will actually see if the referrer was not from Google and say, oh, that's like a blank page. So somebody like started to crawl directly on my website. That's suspicious. So they have a JavaScript code that kind of do something different. So they look legit. And yeah, the way to bypass that, you can either simulate a search from Google to bypass that one, or kind of analyze the JavaScript and try to find. Yeah, it's something. I did try directly from Google, to simulate that, and that worked. But from website to go to the advertiser was a little bit trickier. Yeah, because there are usually 2 or 3 ops that require to find the original advertiser. Yeah, it's not that easy. So you need to crawl more, but then the tree becomes very wide. So yeah, but it's a good question. Okay.
Is that it, folks?
Okay, thank you
very much.
No
And
problem.
others.
Sure. I forgot to repeat the question.
about ZAP Z-Attack Proxy Advanced Features. I have been told that this room is apparently double booked. So if you're not interested in ZAP Advanced Features, you're in the wrong place. so please. Yeah, so anyway. So no one's going yet? Excellent. Okay, no problem. Right, so my name's Simon Bennett. I work for the Mozilla security team, and I'm the project leader for ZAP. I've done quite a lot of talks in the last few years about ZAP, and I've tended to focus on introductory talks, kind of setting the scene, letting people understand what ZAP is, because people haven't known what it is, and I want to just explain what's going on. But hopefully some of you have seen those talks, and hopefully more of you know ZAP. Show of hands, anyone use ZAP here? Lots of hands. That's what I want to see. Right, so I'm really looking to talk about some of the more advanced ZAP features. I will have a quick introduction to a quick bit of background for those of you who don't know much about ZAP. But some of the more basic stuff, the best thing to do is have a look at, my previous talks are recorded, and there's a lot of information online. We've got videos and things. But what you need to know is, yeah, it does the basics. But what I get the feeling is even people who know ZAP very well or use it a lot don't actually know all the functionality that it's got. So I wanted to talk more about that. So a little bit of background for those of you who are new to ZAP. It's a tool for finding vulnerabilities in web applications. Completely free, open source like all OWASP tools. And so there's no pro version. There never will be a pro version. And I always deliberately say that because ZAP is very much a community tool, and I want people to get involved. It is, when I released it, I said it was a tool for developers, a tool for people who are new to application security. And I think that's still very important. That's a really important target market. But ZAP has now moved a long way beyond that as well. I want to make sure it's still an ideal tool for those of you new to application security, but it's a lot more than that. It is used a lot by professionals. We use it within the Mozilla security team, but I know a lot of professional pen testers who use it as one of their tools. But it's also ideal for use in a continuous integration environment, so for developers to automatically do security tests on their applications while they're developing them. That's something I've talked about before. I won't be going into that in any detail this time. And it is really becoming a framework for advanced testing, and that's something that I really want to focus on today. It is included all the major security distributions, and I know that you should never believe online polls, but I'm still going to make the most of the fact that ZAP was voted the top security tool of 2013 on toolswatch.org. And of course, no tool is a silver bullet. It never will be. So this is always going to be part of a possible set of solutions. We have principles. I've said we're all, free, open source. Involvement is very actively encouraged. You may find it difficult to get out once you get dragged in. It's cross-platform, easy to use, as easy to use as we can make it. It's still a complex tool, but we always try and make it easy to use because I want a tool that's easy to use. And it is fully internationalized, which is very unusual for security tools. It's fully documented, and I say that with some caveats. Mostly developers have written the documentation, so it's not perfect. But we do have documentation, so you can look and find more information if you need. But we've got lots of online. We've got user groups, developer groups, so there's plenty of places you can get information. We also want to work well with other tools. So there's tools like ThreadFix, Minion that make use of ZAP. You can invoke other tools from ZAP. We know that in many cases ZAP won't be the only tool you use. We want to integrate well with those other tools. And we also try and do reuse. So we try not to reinvent the wheel. And if there's good open source components we can use, then we will make the most of those. A few statistics for you. So it was released in September 2010 as a fork of Paros. The last release, 2.3.1, was just over a month ago, and we have already had more than 20,000 downloads, which I'm pleased with. It has been translated, or is being translated, into more than 20 languages. So we have over 90 translators working on ZAP, but we always want more. So if you do know a particular language, if English is not your first language and you would like to help translate ZAP into one or more languages, then please get involved. Now, it's very difficult for me to know who was using Zap and how they're using it. People download it and don't tell me about it, which is fine. But I get the impression that the majority of people are actually professional pen testers. I want to get it more into the development market, but the professional pen testers are very important end user as far as I'm concerned. And every so often I see something about Zap being just a fork of Paros. I did some calculations, rough finger in the air calculations, and I reckon that the current code base, only about 20% is Paros code. Over 80% is now new code. We're not trying to get rid of the Paros code, but we're putting new functionality in, replacing things, getting rid of old stuff. There's a site called OLO, which I really like because it gives great statistics on open source projects. And so it has different categories of the number of updates. And Zap is in the top category, so it's very high activity, so it's right up there with the Linux kernel and Firefox. It is the most active OWASP project. And so we had last year, apparently, there are 29 active contributors. So those are people who actually committed code. So it's not including all the translators and people helping the documentation. And apparently, it's 278 years of effort. And I have no idea how they calculated that, because I haven't spent anything like that amount of time on it. But that's what they claim. And all these are statistics you can check up yourself. So main features. It's got features. It's got all the standard stuff that you would expect from a security tool like this, and I'm not going to go through them now because I want to focus on the more fun things. So these are the things I want to talk about now. If you want to learn about some of the other things, then please see some of my other talks. I want to talk about context, advanced scanning, before I get to scripts and something called Zest, and see how I go. I might have a chance to talk about plug and hack. I might be pushed for time. It all depends on how things go. So the first thing is contexts. How many of, most of you here using Zap, how many of you have actually used contexts? No one. I thought somebody might have. No, that's why I'm doing this sort of talk. So contexts are, strictly speaking, they are just sets of URLs. So you can use, they're intended to define different parts of the application. So, or applications themselves, you like. So, we've got typical case of, you've got www.example.com, that's one site, one application. You then have something like, multiple applications on the same site. So, and they can have very different characteristics. So that's a subtree, a subset of a site could be a context. Or a context could actually cover multiple sites. And you could actually have context for parts of applications as well. And this all sounds a bit airy-fairy. So what I want to do is do some demos. So what I've got is the Botnet store, which is my go-to application for doing demos. And I'll just look at a couple of things, and I'm then going to log in as a user. Now, if I go to Zap, you will see that here's our application. And in this particular case, it is a part of the subtree. So I'm going to right-click, and we have this including context option. Basically, right-click everywhere in Zap. Highlight things, right-click on them. We try and only have the main functionality you need visible, and still, some people still complain there's too much there, but there's loads more on right-clicks. And I want to include in context the default context, context 1. Actually, I'm going to rename this to Botnet just to remind me. And so a context can have multiple sets of regex expressions for URLs to include and to exclude. And so that's how you define those. And you can do them manually by typing the regexes in, or you can right-click, include, exclude. So you can, if you wanted to exclude part of it, you could right-click and then exclude from context. But we don't want to do that. So one of the things context do is they define scope. So this particular context I'm saying is in scope, and that affects things like, so we have different modes. I always use standard mode, which is the dangerous one. But if you go to safe mode, you can only do things, actions on contexts that are in scope. So that's how you define the scope. But there's various other things that you can associate with context as well. One of them is authentication. So we have different methods of authentication that Zap understands. Form-based, HTTP, NTLM, manual, script-based. I'll come back to the script-based ones in a bit. Now, you can put these in manually. But as I said, we try and be context sensitive. So we've got this post here, and that was how we logged in. So right-click on that. There's a new menu option, flag as context, and there's only one option, which is form-based authentication login request for budget. So I will select that, and what you'll now see is it's filled out, it's worked out, yeah, it's form-based. That's the URL. We can change it if we want. We can tweak that if we like. Here's the post data. It's actually got all the old post data in, but the username parameter is a username, password parameter, not username, it's password. And, OK, so we now have this new icon. So hopefully there you can see it's a kind of door. So that shows us that that's the login request. There's one more thing I want to do. I want to go to one of these requests, look in the response, because I want to tell Zap one more thing. Here we have this bit of text saying guest user. Now, you only get that if you haven't logged in. So highlight it, right-click, flag as context. We now have different options. That's the logged out indicator. So that's the indication that we are not logged in. I could have typed it in there, but hey, let's use the context-sensitive stuff. So, OK, we've now told Zap a bit more about the application. Why is that of any interest? Well, actually, I'll go and do a bit more, because we can also talk about the users. And I happen to know that there is a user at AppSecEU.com with a suitably... Oh, I meant to put that in the username. It's good there as well. No, I didn't want to do that. I'm going to type it in. It's a demo. .com, and a suitably secure password of password. Hope I got that right. And I'm going to do another one because I've actually got an admin, which is admin at AppSecEU.com. So this is where you can put in all of the users that you have been given to pentest with. So what can we do now? Well, we've actually got, go back to here, we have this forced user mode. So we can actually say which user we want to force Zap to use. And up here you see there's this forced user mode icon, which previously was disabled. And it's still, it's not enabled, but the button's there. If I go back to Budget Store, I'm going to log out. So as you can see, top right-hand corner, it says guest user. Back to Zap, go into forced user mode, click anywhere, and all of a sudden I'm logged in as the user. I can log out, and it doesn't matter because Zap will detect that I'm logged out and log me back in as this user. And I can go back here, and I can go in, and I can say, actually, what I really want to be is the admin. And go here, and I can just click anywhere, and all of a sudden, I'm the admin. So Zap now understands about authentication, it understands about users, it understands about sessions, so you can choose which user you want to be. And this is really powerful because this affects Zap, all of Zap. So you can spider as a particular user, you can active scan as a particular user, you can fuzz a particular user, and you can, it doesn't matter if your application logs you out, Zap will just log you back in. So this is really powerful, and that's just one part of what we can do with context. What I want to do now is, I will come back to this, don't worry. We've got this new budget store, and I'm going to click on a couple of things here. And we've got a different URL, SP budget. And I clicked on a couple of pages, but you'll notice we actually only have, we've got two pages there, but they're both the same one, which is a little bit annoying. And if you look down here, you'll see that the URLs are actually app.jsp, and then the page is actually a request parameter. So what we have here is a single page application. Even though there's multiple pages in the background, as far as the browser is concerned, it's single page. And this is a complete and utter pain, because Zap uses this structure. This is the structure of the application it understands. So if it tries to attack this here, it will actually only attack those pages. It won't attack the rest of the functionality. This is not good. However, what I'm going to do is I'm going to declare this as a separate context. So I don't want it in budget. I want a new context. Just leave it as 2. And one of the other things we can do is we can define the structure. So once you've defined a context, you can associate different things with that context. Authentication, session handling, and things like, how are the key value pairs separated on the URL? How are the key pairs separated on both, so URL and post data, and more importantly, in this case, structural parameters. Now, structural parameters are my term for these parameters that are actually part of the structure of the application rather than being part of the functionality. So I'm going to put page in there, OK that, and go back and start browsing through Zap. And all of a sudden, now, because I've defined this, we have this extra node has been put in. It's not a real node, but it shows us that we now understand this. So previously, Zap would just attack that one page, even though it represented the whole functionality. Now we can actually see the different parts of the application and attack them separately. So the context allows us to teach Zap how the application works. And the more Zap understands, the more effective it can attack these sort of cases. What I want to do now is talk about advanced scanning. So just make sure I'm... So yeah, that's the thing on context. It allows you to define various things. So I want to talk about advanced scanning now. And most of this is going to be demos, so the slides are just for people who didn't see the talk. Hopefully you already know that if you right-click anywhere, then you have loads of options, and the attack option, this gives you, all the active scanning, the spidering. Somebody was asking me about when we were going to support Ajax spidering. We've been supporting it for years. It's there. But one thing we have a new thing, which is the advanced scanning. We can get it in different ways, actually. So from the Tools menu, there is an option for Advanced Active Scan. And hopefully, as you can see, pretty much every menu item has keyboard shortcuts. And these are user-defined. So we have a load of defaults, but you can change them to be whatever you want. At the moment, it's Control-Alt-A. I'm wondering if it should be Control-Alt-Z for Zap and make it the Zap three-fingered salute. What I'm going to do is I'm going to go in via the context-sensitive one, because then it will actually bring up the right. I hate this mouse. Right, so what we have now is this is Advanced Active Scan dialog. Anyone here used it? No. Right, so you have a starting point, and if you want to change that, we've got this nice little thing where you can go through and change it to whatever you want. And it's detected the context, which I'll come back to. We have an option to recurse, but this is a leaf, so that's not enabled, and just in scope, or it's not relevant for this particular one. We have the input vectors. Now, in the options, there are loads of options. All of these things you can configure for the options. The trouble is, they apply to everything. So they apply from that point on, whereas the active scan, you can just change them on the fly. So you can say exactly what things you want, whether it's just the URL query string, the path, post data, anything like that. So you've got fine-grained control, and you can change that whenever you like, and that doesn't affect the main. If you just say scan from here, it'll ignore these and just use the standard settings. More interestingly, we have the custom vectors. And this is fun, because what you can do is you can highlight absolutely anything in the request and add it. And you can do multiple things. And these then are used as places we're attacking within the request. You can't do this when recurses, because obviously you've got multiple inputs, requests. But if you've just got one request, you can choose exactly what you want. And you can actually say, well, OK, I don't want to attack anything unusual. I just want to attack one parameter. But I only want to attack that one parameter and not everything else. And then what we have, if I stay on that dialog, you can actually disable the non-custom input vectors. So I sometimes think some people use Zap as a very blunt instrument. You've got the quick scan button, you've got the attack, it just hits it with everything. Very script kiddie. Zap can be a very sharp scalpel. We can say, right, I just want to attack this particular part of the request, and when it comes down to it, I know exactly what I want. We've got the policy, which again applies to everything if you like, but here you can say, well, actually, I don't want to do all these things. So we can set all these things to off. Because what I really want to do is I just want to attack this one parameter with reflected cross-site scripting. So turn that back to medium and then start the scan. And it won't do very many attacks because those things weren't vulnerable. But it shows that you can focus down and say, right, this one particular parameter, I want to attack it in this particular way. And one thing you can do, so actually what I'll do is, hopefully down here we can look at the request. Actually, no, look at the response. And we'll see what Zap does. It always attacks as the last session, essentially. So we're doing this as the admin, but I didn't really want to do that. So what we can do is we can go click Advanced Active Scan, add that, just something relevant. And what you notice, because we detected what context is in, we can choose users. So I actually want to attack it as this particular user. And we have a look at this one here now. We should see we use the user. So what the active scan dialog does, it allows you to focus down to exactly what you want. You can include lots of all the standard input vectors, or you can say just a particular thing and say exactly how you want to attack it and which user you want to attack it with. So this is really powerful. And we're going to carry on adding to that, adding more options, and probably things like the spider and stuff. We're going to start adding these sort of advanced dialogues so you can get it to control it exactly how you want. So what I want to do now is talk about scripting. Zap has a very powerful scripting support. What we realize is that when you're doing a pen test, you'll find situations where you have to change Zap to handle the application better. The problem is, it's great there's open source, but do you really want to have Eclipse there, download the latest Zap source, build it and change the source code? You probably don't. So what we support is scripts, which we try and plug into as many places as possible. So we've got different types of scripts. We've got standalone ones. What I'll do is I'll try and show you some of these things. So we've got this new scripts tab, and you can see all of these different things. So these are the different types. We have templates as well. So if we have a look at some of the standalone ones. So one of the things we can do, loop through the history table. Looks like a Python script, so I will just make a new script out of that. And once we've got one of those, we can run it. And there, it'll just go through the history table. Obviously, so this is just kind of a template thing, and you can change it, do whatever you want. So standalone ones, you tell Zap when to run them, and they just run. We also have targeted scripts. So let's have a look at some targeted templates. Resend as a GET request. So right-click that, make it a new script. And this, okay, in this particular case, you can run them. But what it'll do, it'll actually ask you what values. So if it wasn't a Zest script, you wouldn't be able to run it straight away. But what you can do is you can go to the sites tree. Oh, actually, it might be easier if I go to the history tree. Here we've got a post message. So we can right-click this, and there'll be invoke with a script and resend as GET request. And towards the bottom, yep. So I then just submitted that, resubmitted that post as a GET. So with targeted scripts, you have to tell Zap what request you want them to run against. We have active scripts and passive scripts. So these run in the active and passive scanners. So you can use these to detect vulnerabilities actively and passively. Proxy scripts run in line. So these actually change things dynamically. And so we've probably got another. So these ones you can't run at all. We go to scripts. So here, another one for changing all the posts to gets. And this is different in that, so that one, again, what will happen is that will be, when you enable that, that will actually only happen when requests go through Zap. So you can't, I mean, we do allow you to run it, but then you've got to put all the parameters again. So but normally the proxy ones will happen when they're enabled on every single request. So you can then put whatever conditionals in to affect so that it runs when you want it. But we also have things called authentication scripts. So Zap understands sort of form-based authentication, those simple things, but there are often cases where you have really complex authentication, or even just not particularly trivial. We have one option here for WordPress authentication. So this handles WordPress, because apparently it's non-trivial. I didn't write this one, luckily someone else did. So what it means is that if you have an application that uses some non-standard authentication, with that context, there was an option for scripts. So you could actually say, right, this is a WordPress site, this is a script I want to use. And you can write these things, we try and make it as easy as possible, so you can actually either download one or implement one to handle whatever condition you want. So this means it doesn't matter how complex the authentication is, Zap will be able to handle it. And finally, we have input vector scripts, and these, so I think we've only got we've just got template ones. Oh no, we've got a input vector sharp query separator. So I don't know anything about this, but basically the input vectors are how Zap understands the request and how it attacks them. So if Zap isn't attacking the parameters in the right way, maybe they've been encoded or something like that, you can write an input vector script that allows Zap to understand how to attack those things. So it means Zap can attack however the application in the right way. Now these things are all well and good, but the problem is you still have to know something about the Zap internals. You have to have some idea of how, the syntax of the language and so the scripts are really powerful because what they do is that you have full access to the Zap internals. It's an open source product, so we're not going to hide anything. But what it does mean is you still have to know how to get these things. We document these things, we document it as much as possible, but still you have to understand the syntax, and it's non-trivial. So what we've got this new language called Zest, and this is it's more of a macro language. And I showed you one of these things before, which was so go to the resend as a get request, and this is what a Zest script looks like. So it's actually graphical. The request, it's actually JSON in format, so it's pretty horrible. You wouldn't want to write that. But what you can do is you can just right-click anywhere, and it will show you all of the options you've got. So you can put in conditions, you can put loops in, and in this particular case, we're saying if the request is post, then we want to check to see if it includes a regex, then we just want, it includes a question mark, then it's already got parameters that we want to append them. Otherwise, it hasn't got any parameters, so we can just put them in after the question mark. So you can very quickly put scripts together which do very powerful things. And this is completely integrated within Zap, even though it's completely separate from it. Now, Zest is particularly powerful. I'm going to skip most of these. But it's got various... Now, I mentioned authentication before. One of the big problems that I have in Mozilla is something called persona. It is a complete and utter pain. So it's a single sign-on system that actually relies on the browser. You really have to have a browser. And so it uses client-side cryptography, so public and private keys. It is really hard to script unless you have a browser. That was one of the things with Zest. It's great on the server side. It's kind of a wraparound doing your server-side request responses and manipulating them. But the plan always was to actually move Zest into the client side. And I've just been working on that. It is not released, but the code's checked in so you can play around with it. So what I'm going to do is I'm going to create a new standalone script. It's going to be a Zest one. And what I'm going to do is, so you for Zest, you just right-click, and we've got this new option for adding Zest client. And I'm going to launch. So I'll call it, we have to have some handle, so window 1. Use Firefox, of course. And I'm going to go to budget. And if I run that, to go to the comments page, to right-click, add this client. I want to click on something. I've got various choices. Go for partial link text. Go for com. And so if we run that, then we'll go to the comment page. So we have so we can now control the browser, which is kind of interesting. But a couple of things. One, it's a little bit of a pain to go through all these things to contribute to the script. It's not too bad, but a little bit of pain. And then two, why would you use this? How would it be useful? So happens last week I had a persona application protected by persona to test. And this particular application, once you'd logged in with persona, allowed you to put your username in. And this username is then used elsewhere in the application. So this would be good for persistent cross-site scripting, wouldn't it? Trouble is, I've logged in via persona, I've chosen my standard, simple username, and then I can't change it because the application doesn't allow it. So I've now got to go and register a completely new persona ID to do this. And persona, so it's a very, you have to have a browser, and then you have to, it sends you an email, and you've got to OK that. A complete nightmare. If only I had a way to script that. Can you guess what's coming? So I'm actually not going to run the script because the Wi-Fi here is awful, but I have got a recording, and so here the script, which I'll show you in a minute. So we are now going to persona, and what I'm doing is I'm putting a randomly generated mailinator.com address in there. Persona's going, well, you're not registered, so we'll send you an email. All well and good. What can we do? Well, we can now go to mailinator.com for that particular user. And this is a nice Ajaxy thing. We wait until the email comes along. Email comes along. We click on it, and we then say, OK, final thing, last step, log in, and there we are. We have a new persona account. Now, that actually, so that is the script which I've got. It's one of these ones. So that is the script. And I actually put some sleeps in valid. So what I could do, I actually could create a Zest script. I wrapped this, so I was able to fuzz the username, which was protected by a single sign-on system that required email authentication like that. Well, Zest scripts, there's no concept of, Zest, OK, it does server-side operations and client-side operations. But they're all the same script, and these scripts can be used anywhere. So you could create an authentication script that actually creates a brand new user. And then you can tell Zap how the authentication works, except it's not really how the authentication works, it's creating a brand new user. You can start scanning, you can put Zap in forced user mode, and then you get locked out. Zap goes, oh, no, you're no longer logged in, we're going to run the authentication script, which then registers a completely new user for you, and carries on. And then you get locked out again. Oh, we'll just create a new user and carry on like that. So I think there are a huge amount of possibilities here, and I want people to play with it and have some fun and see what you can come up with. And when you start pushing this stuff, you will come across things you can't do or doesn't, bugs or ways it doesn't work in the way you want it to. Let me know, because this is still early days, so I haven't actually released this yet. Most of the code's checked in, so you can try it out. But there will be problems. Please have a play with it, and yeah, let me know how you get on and what you suggest for fun things to do. So I'm going to go through this quite quickly because I have demoed plug and hack last time in AppSecEU and USA, so you can see the videos for that. So plug and hack phase 1 was all about, one, making it easy for browsers and security tools to work together. So in Zap we have this on the Quick Start tab. We have a plug and hack button that will then launch your default browser and allow you to configure that, as long as it's Firefox, to work together. We would like to support, we're trying to get the other browsers to support it as well, but no luck yet. But what it does, it gives us a hook into the browser. What we've done in phase 2 is we can allow it to inject JavaScript. We don't do this by default because obviously it's changing things. But what it does allow us to do is handle things like the post message API. So we can actually intercept and change post messages even though they are completely on the browser once you've injected this JavaScript. And one of the demos I did last time was fuzzing post messages and actually finding DOM XSSs in post message, which is kind of cool and not something else that any other tools you can do, as far as I'm aware. But one thing I wanted to mention was that phase 3, we're working on phase 3. I was hoping to demo it today, but we didn't quite get it working in time. We're carrying on with the client side because it already showed you various events, and what we're doing now is exposing more events because it was quite a pain to do the launch this window and then click on here. What we're doing is allowing plug and hack to enable client-side Zest recording. So you'll be able to say, right, I want to record this client-side script, and then it will launch a browser, you will do your stuff, and it will record everything in Zest format. And then you can rerun that, you can change it, you can tweak it. So it's work in progress, but it's nearly there. Talking of work in progress, we've got a lot of fun things going on. One of the big complaints is the fuzzing, and I hear from people there's fuzzing in Zap. It's really good, really simple, but you can only fuzz one parameter at a time. So Sebastian is working on, for the Google Summer of Code, is working on advanced fuzzing. That will allow you to fuzz multiple parameters, but actually give you a load more things you can do. So that's going to provide a lot more advanced functionality. And he's already released something, so very much alpha status at the moment, but you can download that from the Zap Marketplace and have a play with it. We want feedback on all these things. Cosmin is working on advanced access control testing, and this is really fun. As I've mentioned to some of you I've already talked to, Cosmin is the third year he's been part of the Zap team for Google Summer of Code, and he's carried on working on Zap in between as well. His first year he rewrote the spider to make it much more effective. Not the Ajax spider, it's a different student, but so the standard spider. And he got the understanding of sessions handled properly. Last year he worked on authentication, so all the authentication stuff you saw in the user understanding and understanding roles, Cosmin did that. And now we've got that basis, he's working on automated access control testing. So we can actually understand, we have all the pieces, we can put them together and we can do some very advanced stuff on that. If you want more details, then grab me afterwards, either here or on the open source showcase. Alberto is working on SOAP service scanning. So again, I think he's got an alpha add-on already available, so that will take a WSDL file and populate the sites tree, and he's already started doing web service specific attacking on that. Then we've got a couple more students who are not part of Google Summer of Code, they're just doing it as part of their master's degrees. Lars and Stefan are working on sequence scanning. So by sequences I mean things like your kind of wizard interface where you have page 1, page 2, page 3, and at the moment, Zap, like pretty much all scanners, will go page 1, parameter 1, attack. Page 1, parameter 2, attack. Page 2, parameter 1, attack. And the application should go, you're out of sequence, go back. But, it'll just carry on blindly. So the idea is we're going to allow Zap to understand sequences. What are sequences? Well, they're Zest scripts, because Zest gives us that structure. So what you'll be able to do is say, scan this Zest script. And basically then Zap will go, page 1, attack the parameters. Page 2, parameter 1. I've got to go to page 1 first. then attack parameter 1 page, and it'll actually go through the sequence correctly, but still performing all the attacks. And then Avinash is looking at sequences again, but looking at abusing the sequences and trying to work out ways to skip things and go between different users and different sequences. And I think he's already found a significant vulnerability in a major web application, which I'm not allowed to name, based on his research he's been doing with Zap. So a lot of fun there. A couple more Google Summer Codes, which aren't really directly Zap related, or only slightly, but OWTF is adding both Zest and Zap integration. And we've got a Google Summer Code student working for Mozilla, which I've already mentioned, working on this Firefox Zest add-on. So that means you won't have to ask people to install Zap. You can just say, download this add-on, press record, reproduce your vulnerability. Doesn't matter whether it's client or server side. And then we'll have a Zest script you can attach to the bug report or send off to the company and say, here's my proof. Here's how you reproduce the vulnerability. Really nice and easy. As I said, there is more stuff going on behind the scenes, which just to let you know. One last thing I want to say is the source code. So the source code currently all on Google Code. We will probably move to GitHub, but I just want to make sure all the issues and everything is moved across as well, and history and things, so it's a bit of a messing around. But I want people to get involved. I've got a Hacking Zap blog series. There's 4 posts on there at the moment which explain how to set up the development environment and take you through things like passive rules and active rules. And we've got simple examples you can take and you can play with and you can customize. Got a lot of information on the wiki, the internal details, but you can never have enough documentation. And really what you want to do, if you're interested, get onto the Zap developer group and get in touch and just let us know, what you want to know. And we will help you as much as possible. So I'm trying to leave some time for questions. So I'm going to wrap up now by basically saying that my conclusion is Zap is changing very rapidly. There's a huge amount of stuff that's going on right now. It is the most active OWASP project. I don't think anyone denies that, co-project anyway. I'm now claiming it's the most active open source web application security project. No one's disagreed with me, so it must be true. So, it really is good for people new to application security, but I'm saying it's actually really great for security pros as well. If you're new to application security, you're a developer or something like that, I think Zap is the only web security tool you need. If you're a security pro, you should not be using one tool. If you only use one tool, you're doing it wrong. Or at least if you only understand one tool. You should understand the capabilities of all the main tools out there, and then you should choose the one that's most appropriate for you. And I cannot tell you what that is. But if you don't understand Zap properly, then I think you're doing it wrong. You might not be using Zap, but if you understand what it can do, then use whatever's right for you. But I do want to say at the end, it is a community-based tool. Please get involved. I want more people involved and more people to play with stuff. And that is it. So who's got the first question?
Do you plan to integrate DOM-based XSS automation scanning?
Okay, so the question was, do we plan to integrate DOM XSS scanning? Yes.
When?
So I was hoping to have done it by now. Got sidetracked by the Zest stuff. So clearly what I've been doing is working on the client-side scanning. So both plug and hack and the new Zest changes are all very much client-side. And this was very much all working towards client-side scanning. And this is generic client-side scanning rather than just DOM XSS. So what I want is actually have an infrastructure. So we have passive scanning, active scanning, client scanning. And then that'll be a plug-in thing, and you'll be able to write your own rules, if you like, and download them, exactly the same sort of infrastructure. Not sure exactly when, but that is definitely, that's the direction we're going in. There's another.
Yeah, I just want to know what browsers can be driven by Zest scripts, where you go through the launch browser, just Firefox.
Yeah, so the question was which browsers can be launched through Zest scripts. We're actually using Selenium. So I haven't finished, this is not, I haven't released it for a reason. It's still a little bit flaky. Right now I'm testing with Firefox, and Firefox, not surprisingly. But I want to make sure that it works with pretty much all the browsers that Selenium supports. It certainly should do. We just need to make sure the configuration is there. I definitely want it to work with Chrome and IE. I want it to work with headless browsers as well, because I want to do that persona login completely headless. So your Slammer JSs and things like that. One of those I will definitely make sure it supports. And if there are other things, I think I've already got something in there where you can within Zest you say you can give, there's a set name, so you can put in IE, you can put in Firefox, you can put in Chrome, or you can put a full class name in. And if that class name is a web driver, then it will use that. So in theory, it will be anything, but obviously in practice, then there might be some glitches, in which case, yeah, pull request welcome.
Are there any best practices or recommendations or documentation regarding to implementing ZAP, using ZAP into binary dimension process, so focus on automation?
So questions, are any advice, best practices for integrating ZAP into security automation testing? No, unfortunately. A lot of people are doing it, so we're doing it in Mozilla. I know various other companies are doing it. We haven't really pulled those best practices together. I think a lot of situations are they're all a little bit different, but it'd be really great to pull people's experience together. And we've got tools like ThreadFix, which is really good. And we've got Minion within Mozilla, which can control multiple security tools. But I'd really like ZAP to put in different CI environments, as many as possible, and have device and guidance around that. We haven't really got that, but please come onto the developer group, ask questions, and we'll try and pull that together, because, yeah, we could really do with that. And if you've got any suggestions, then let us know.
So is the direction you basically would be wanting to look into again?
Yep, so I see there's three main use cases for ZAP. One is people new to application security, developers QA, so using ZAP as a kind of point and shoot tool, and then learning about security more. Then you've got the professional pen testers really focusing on the manual stuff and using the automation just to cut down the amount of work they have to do. But then ZAP in a continuous integration environment, proxying your regression tests through ZAP, so that explores the application and shows ZAP how it really works. So that your developers check code and a couple of hours later you get an alert to say you've got a cross-site scripting vulnerability because they forgot to escape one parameter. And you get that within hours rather than a week before you go live when you run the pen test. So yeah, that's a real key use case for me for ZAP. So yeah, we could really do with some more documentation around it, and yeah, help appreciated.
First of all, fantastic.
Thank you, Jerry.
I'm so excited when I'm in these Zap first, because every time you give it, it's like there's more features and there's.
There are.
Yeah, it's really amazing. Like even just the beginning when you're talking about like switching to various personas, like my heart started like racing. That said, Minion. What's the status on Minion? Because I know that you're using part of ZAP and part of a larger service. So where's that?
So Minion is another tool developed by the Mozilla security team, and it controls different security tools. And this is very much a kind of web interface, and we wanted it to be something that a security teams could set up for their developers. So developers could go to Minion on an internal site, say this is where my site is, and I want to run Nmap against it and ZAP against it and all these other tools. So yeah, it's still in development. We had a little bit of, one of the developers had time off and things, so it hasn't progressed as much as we wanted, but I think we've got some Google Summer of Code students working on it now, so yeah, it's moving forward. I'm not directly involved in it, but I'm obviously indirectly involved. And all this thing with the persona integration, that's key for Minion and all these other tools.
Two more little sub-point questions. These would be super quick answers. Number one, I know we've talked about this before, but I guess with ZAP, can a normal developer like myself, can I pull out parts of it and then use parts of it in other applications? How modularized is it? Like, it's specifically the, we're talking about like the spidering and the Ajax spidering and so forth. That's something I have to do all the time, right? Can I pull that out and use it?
Okay, question is which bits of ZAP can you pull out and use? ZAP is kind of modular inside, but we haven't designed it that much to be completely reusable. There are some exceptions. So Plug and Hack was designed to be tool independent, and Zest is absolutely tool independent. So Zest is actually a standalone runtime. So we have a Java runtime, but Obviously, we've got the Google Summer of Code student writing a JavaScript runtime. You can write it in whatever language you like, and if you'd like to write a Python or Ruby runtime for Zest, please get in touch. The Ajax Spider is based on crawljax, so that's another open, which then uses Selenium again. So crawljax, yeah, you've got a good chance of reusing. But yeah, some of the other bits are a little bit too integrated. But give me a shout off, in the development group or offline. I'll try and help you to, because we want to develop components that can be reused. But a lot of the stuff we do is kind of tied into other Zap things. So
I can drop you emails on,
yeah.
on various stuff. And then you answered the second sub question, which is I was 99% sure, but you can script most of Zap headlessly.
Yeah. Yep. So Zap runs headless. So we've got a daemon mode, and it does. So we've got a REST API to that. And it's very powerful. It doesn't allow you to do everything, but we're getting there. And if there's anything you want the API to do that it doesn't do at the moment, then get in touch and we'll kind of accelerate that or give you some hints on where to start implementing. But I really want the API to be fully functional, so it doesn't, we'll have a clean separation with a Zap functionality, and it doesn't matter whether it's been driven by the UI or the API. So that's the end goal.
Awesome. Thank you.
Next question. No more questions? Right, that's it. Thank you very much. I'll be around here. We'll be up in the open source showcase later on, but yeah.
in a variety of web application firewall vendors. And as part of my job as a security researcher was a small part of the job, but very significant one, was to look into the data, to look into the result of the web application firewall, the triggers that were triggered by the WAF. And by looking on those triggers, I was trying to see, well, if there are false positives over there, if there are all kind of attacks that are being detected. And while doing that, well, some thoughts crossed my mind about why we are not utilizing that data, why we are not taking all the data that we already have, that was already fired, that was already triggered, and saved, and try to find all kinds of things that we can do with this data, all kinds of insight that we can get out of this data. And this is exactly what I'm going to talk to you today, an actionable intelligence by analyzing WAF triggers. And before I will start with a short story about this kind of analysis, I will say, well, an important note about the things that I'm going to talk about. All the things that I'm doing are based on mod security core rule set, meaning that's the baseline. The triggers that I have, the analysis that I was doing, those things that I'm going to talk to you today are based on mod security. And while I won't say that a lot during the presentation, that's the baseline, it's important to know that. So let's start with a story. And in the story, one of our customers, which is usually happens, calls us and tells us, well, guys, I'm being attacked. What really happened out there? And each kind of such attacks start with a very basic analysis of the data. So we're doing drill down and look on the triggers that were fired. And in this example, when looking into the data, when doing a deep dive into the data, we can actually see that someone is sending a remote file inclusion attack, trying to exploit a WordPress plugin vulnerability. To those of you that are not familiar with RFI, the basic concept is that someone is trying to inject remote source code located on remote server into your application, and by doing that, it will probably own your application or have full control on your application, which is pretty bad. And in this case, well, when looking into the data, so you see the name of the parameter that is trying to be injected, which is WordPress path, and you can see the remote source code that someone's trying to inject. And in this case, when looking at that, well, I was able to see that this is a page that's located on Google's humans.txt. Doesn't make sense. So I went to that page and looked at it, and it's a textual page. That's funny. So while doing that analysis on those kind of requests, I had some questions that crossed my mind. So the first one, I looked at that exploit that we just saw. It's an exploit from 2007. Why should someone try to exploit an vulnerability from 2007? You would expect that such vulnerability will already be mitigated. So what he's trying to do here? The second part is, well, I know my customer, and I know that his platform is .NET, and someone is trying to inject PHP vulnerability, well, WordPress PHP vulnerability to the application. Why is he doing that? That's not smart. And the third part is, well, we talked about it. It's the legitimate page. It's the humans.txt page on Google. Why should someone use that page? Doesn't make sense. And we'll go back to those questions. But before doing that, well, I stored all the data of that customer, and I went to that data. This data is stored in a database, and I have the ability to query this data. So I started querying the data, and the first question that crossed my mind here was, let's try to figure out what that malicious guy that I saw sending those attacks before, what he was doing on that specific application in the past week. And I was able to see that he was sending more than 2,000 unique remote file inclusion attacks to that specific application. That's nice. But I had another question that I want to ask to query the data on. And that was, well, maybe I will try to see. I know that my customer has numerous applications, so let's try to see if that specific bad guy is doing all kinds of attacks on other applications that I'm not aware of, that customer. And in this case, well, I found out that there are 12 different applications being hit by the same malicious actor. sending more than 11,000 attacks on a time frame of 1 week. But that's not enough. And I decided to take it one step further and try to find, well, we'll get back to that, but try to find similar activities. We will try to explain what does it mean, similar activities. But the basic concept that I want to check if there are other bad actors behaves the same as the actor that we just saw, the attacker that sends the attacks, and try to figure out if there are other attacks. And in this case, and this is the interesting part, I was able to see a bot network hitting my customer using more than 50 machines, most of them, by the way, compromised web servers that are being used as attacking tool, and sending over 500,000 attacks on a time frame of 1 week. So we had some question open from before, and well, these are the answers. The first one was why exploit from 2007? And the answer is quite simple. The attacker is trying to be lucky. That's what he's trying to do. He's shooting all over the place, and that's what happened. The second question was why using a legitimate page? Why using Google's domain and putting a page from Google? And in this case, well, the attacker is just trying to find visibilities, trying to see if the application is really vulnerable. And once he knows it's vulnerable, then and only then, he will use a remote source code with an actual code injected into the application. You don't want to reveal the source code that he's trying to inject on the first try, because he doesn't know if there are vulnerabilities. And the last question was the why sending PHP to .NET application, and it's the same as the first one. He's trying to be lucky. He's shooting all over the place. We saw him sending attacks from 2005 till 2012, meaning exploits that were discovered between those years. He's using every tool he can get in order to find exploits. So in such cases, well, when I see such an orchestrated attack, I'm trying to find insights. I'm trying to find, well, what can I do with it? What can I learn from this attack? And I found something, well, that are interesting from that attack that I need to consider. LCD, lowest common denominator. The lowest pattern that I can retrieve from all of the attacks that I saw that Botnet sending, it's humans.txt. The second insight was, as I told you before, some of the attacks came from compromised web servers, meaning their IP addresses are fixed. They are not changing. They are not dynamic. Therefore, well, if now they were used for remote file inclusion, maybe in the future they will be used for DDoS or DOS or scraping or whatever. That's an important thing. And the third part here, well, I can see that when attackers send those attacks, since those, well, accessing to pages that does not exist, well, what we actually see is that the attacker generates a lot of 404 page not found on the application, which is something also interesting. And the last thing here is, well, as we saw before, is trying to access many applications at the same time, and that's also interesting information. So that's cool, but what can I do with that? And that's the second part. I was saying to myself, well, maybe I can try to create some actions out of those insights. Maybe I can try to change from theory to practice. And these are the things that I can do in order to improve my security. First one, low-hanging fruit, the first one. Well, maybe I should try to create a ad hoc signature looking for humans.txt in a payload of requests. Well, if I will do that, yes, of course, core rule set is supposed to detect all the attacks out there. But in practice, we know that there are some cases when we miss some of the attacks. For instance, if I'm not doing the proper deployment, or if I'm not applying the right rule, or if, for instance, someone is trying to use a zero-day attack, then the core rule set will miss those attacks. And if I have this kind of ad hoc signature, well, maybe I can do better security. The second low-hanging fruit here is, well, we saw those IP addresses. They are fixed IP addresses sending a lot of attacks. Why shouldn't I continue try to get a request from those, well, malicious IPs? Maybe I should blocklist those IP addresses. And the third thing that I can do here, well, I know the behavior of the attackers. They are creating a lot of page not found responses from the web server. Well, maybe I should count those 404 coming from the web server. And if I see someone sending a lot of requests responded by 404, maybe I should tag those IP addresses that send this traffic and block them. And this is exactly, this example that we just saw, this is exactly what I'm going to talk to you today. I'm going to talk about the benefit of advanced WAF triggers analysis. What we can do in order to improve our security, in order to take the web application firewall and add another layer on top of this, another security controls that will help us do better security. So there are three things. The first method, we are going to talk about three methods. The first one, detection and mitigation, creating actionable intelligence. And it is quite similar to what we just saw. The second part is analysis. Well, we are trying to take all the data, all the WAF triggers data, and try to find out, well, if someone is trying to target a specific part of my application. Maybe someone knows a vulnerability that I have in my application, and is trying to tackle that vulnerability. These kind of insights can only be achieved by doing post-processing of the data of the WAF triggers. And the third thing here is reporting. It's quite trivial, but I still wanted to mention that. If we take all those triggers and try to find out what really happens out there, what are the threats on our application, maybe I can create enhanced executive report. Maybe I can take this report into my exec team and get a lot of benefit by doing that. So we'll start by detection and mitigation. And in order to do that, we will talk about 5 techniques. Before the techniques, what's our objective here? Our objective is to find attacks, to improve mitigation, and we'll try to be one step ahead of the attackers. If we will find ways and techniques that will help us to be one step before they are coming to our application and be ready with the right mitigation and with the right security solution, that would be great. So as I said, we are going to talk about 5 techniques that can be used in order to do all those detection and mitigations. The first one is IP reputation or IP blocking, where think about it like that. There are a lot of malicious actors that are sending a lot of attacks to my application. Maybe I should try to, well, look at their traffic on their malicious traffic over time and try to realize if they are doing over and over attacks on my application. Maybe I should classify them and say they are malicious, and there is a reason why they are malicious, because I saw them sending attacks in the past week. And maybe I should also look on the attack types that they are using. If they are using DOS or scraping or remote file inclusion or SQL injection, maybe I should classify them by the attack type that they are using. Maybe I should also, well, take those malicious guys and do counter probing. Well, I should check all kind of things about those malicious guys, try to figure out where they are coming from, their geographical location. Maybe I should check if they are coming from a proxy or not, anonymous server. Maybe I should, well, try to figure out if they are web server, as we saw before. I can challenge those IPs and check if those IPs are web servers. Then web servers are not supposed to send traffic to other web servers. It's not supposed to happen. And the final point here is, once I will do all those things, I will have context-aware or context-sensitive mitigation. I will be able to put a different mitigation to all kinds of attackers. If someone is sending a lot of traffic to my application and is probably doing scraping or DOS attacks on my application, well, maybe I should start by doing a rate limiting on that malicious IP, and by that, lower the amount of traffic it generates. But if someone else is doing SQL injection, over time, maybe I should just block him and not let him access my application. The second technique here is ad hoc signature, and we talked about it. Well, if we will take the payloads of the attack and try to analyze those payloads and try to find all kinds of things that we can do with those payloads, maybe we can create a dynamic or ad hoc signatures. And the first example is the humans.txt that we saw before. But in this case, well, I'm actually showing you 3 different HTTP requests, different user agents, well, different exploits. It's not the same exploits that are being sent here. But there is one common thing about all those attacks, and that's the payload of the attack, the source of the remote source of the code that someone is trying to inject. And that's the common thing that we need to protect here. We should create signature based on that. The second example is file upload attack. And in this case, well, I took it from an exploit tool. They're trying to inject a page to a vulnerable, well, plugin. It's Joomla plugin as far as I can remember. And by doing that, he's using, and I don't know if you see that, but that's the name of the file that he's trying to upload. Well, if that's the name of the file that he's trying to upload over and over again on many different applications, maybe that's the signature I should use once he's doing that. And once he will do that, well, I have no doubt that he is malicious, and I should block him. Maybe this request will not be detected by mod security. There's no actual, well, there's no actual attack here. It's just trying to check if he can use an exploit, specific exploit for a specific event, well, specific, well, vulnerability, trying to upload a page to application. So now we are coming to the third techniques. And here we are just, well, we are changing a little bit the discussion here. And instead of finding a thing to improve our security from the WAP perspective, now we will talk about taking the payloads of the attack and trying to use those payloads as an outbound filtering. An outbound filter that each organization has that, well, help the organization prevent the users, the clients of the organization, going out to malicious websites. And in order to do that, we're going to talk about WebHive. I don't know if you are familiar with WebHive, but the basic concept with WebHive is that it's an application that someone puts on any given server. And once you get into that application from your browser, browse to that application, the only thing you need to do in order to start being an active denial of service attacker is 2 things. Put the target application, the application that you want to attack, and press the start button. Once you do that, your browser is becoming the attacking tool. Your browser starts sending a flood of HTTP requests to the target application. And here is an example for such HTTP requests going to the target test.com. And this is the referrer, where this request came from. This is the actual WebHive application that was accessed before the attack started. Now, if I can take this payload and find, in this case, the malicious domain, it's a domain that hosts that malicious application. Now, I don't want my clients in my organization going out to such domains. Maybe I should add that to the list of domains that shouldn't be accessed from my organization. So we had 3 techniques, and now we're on the 4th technique. And in this technique, we are going to talk about bot network mitigation. It is similar to the thing that we just saw in the story at the beginning of the presentation, where we are trying to find similarities between attackers in order, well, to find a relation between the attacker, trying to understand what really happens on my application. And again, an example from the thing that the thing that I saw in the story at the beginning of the presentation. I have here 3 different HTTP requests, HTTP attacks actually, trying to exploit remote file inclusion vulnerabilities. Each of the vulnerabilities are different. Each of the headers, the user agent headers, are different. The IPs are different, right? but there is one common thing about them. And this common thing makes me or gives me the ability to create a relation between those IP addresses and understand that I'm being attacked by a bot and not by an individual attacker, which is important because when I want to protect and have good defenses to my organization, I need to understand when I'm being attacked by a single attacker, or is it something orchestrated? It is something that, well, someone is investing a lot of resources in order to attack me. I need to be prepared for that. And for the final technique, well, in this case, what we want to do is we want to try to find if someone is abusing my application by doing an excessive access to my application. And here it's, again, example that we saw before. If someone is accessing many times to my application and getting many 404s or application errors, 500, or whatever response that we want to monitor, maybe we should try to figure out if it's a scanner, trying to find pages that does not exist on my application, trying to find exploit. If I use that technique, I may find things that while just looking at the traffic of the attacker, I won't find. And why is that? Because if someone is just doing scanning on my application, he's not sending a text. He's just trying to access pages that does not exist. But I will be able to find him, and I will be able to pinpoint at him. And I will be able to be ready before he will start sending those attacks, because I saw him doing reconnaissance on my application, which is good. So we talked about detection and mitigation. And now the second technique is analysis. And in analysis, what we are trying to do is, well, we are trying to find those bad actors that are trying to target two types of things on my application. The first one is, well, they're trying to target all kinds of assets that I have in my application, whether it's my database, whether it's a search page, whether it's an open source plugin that I added to my application. Knowing what the attacker are trying to target is very important for me to be, in order for me to be ready in advance to the next step. And the second part is, well, if they have found vulnerabilities in my application and they're starting to target those vulnerabilities that I'm not aware of, well, I want to know that. And by doing analysis on the data that we already have, we will be able to do that. And again, example for that. The first case here is, well, I want to know, and the example talk about SQL injection. I want to know if the attackers know all kind of thing about my schema, my database schema. For instance, if he knows the names of the fields or the name of the table, well, he's smart. Why he's smart? Maybe I have an information leakage. Maybe this information was leaked and now he's trying to target those tables and fields in my application. Maybe he knows what kind of application I'm using, if it's an open source application, and he knows the names of the fields in the database of those applications. If this is what he's doing and he knows what I'm doing, what he is doing, I want to be prepared for that. And the second example is, well, if I will look at the response of the web application and try to find out if there are SQL exceptions, like an information leakage that gives all kind of indication, well, I will know if I have vulnerability or not. If I can see someone sending a SQL injection payload, and at the same time, my application return a SQL exception, well, that means that most likely I have a vulnerability in my application, and someone is targeting that vulnerability. It's not just a SQL injection event that happens on my application. This is something more severe. There is vulnerability and someone is abusing that. So we talked about detection, mitigation, analysis, and the final part is reporting. And here what we would try to do is we try to create enhanced executive report that can help us in numerous ways. The first one, well, it will help us present attack-oriented reports. Meaning, it's not just saying, well, theoretically, or, well, the common practice, or this is the trends in the market. I'm saying what really happened on my application on, let's say, the last 3 months. What kind of attacks were on my application? That's very valuable. The second part is, well, I will be able to say, or will be able to demonstrate my WAF ROI. If I can say, well, I invested a lot of money in deploying and purchasing web application firewall, and this is my ROI. These are the results of doing all this effort. Well, I can do that by, again, by analyzing the data that was created by the WAF. The second bullet here is, well, I can also show my ROI. I can also show that I am professional, that I know what I'm doing, that I'm a security expert, and, well, it can be also thought about as job security. I know what I'm doing. I know what kind of analysis I need to do. I know my mitigation. I know what really happens out there. And the final bullet here is, and that's trivial one. Well, what we are trying to do here is we're trying to make security accessible to those that are not understand security. Well, to those that are not experts. So, in order to finalize all the things that I just spoke about, I decided to do a case study. And in that case study, I took one application that I monitor, and I was looking at 48 hours of all the WAF triggers that were created on this time frame of 48 hours, and these are the results. When looking at SQL injection attack, I was able to find 108 IP addresses that sends attacks. Doing a counter-probing on those IP addresses, I was able to see that 40% of those IP addresses were actually proxies. So here you can see the map of where those IP addresses came from in the world. By the way, most of them came from the United States, just because the proxies, because someone is using proxies in order to send attacks, and using a proxy coming from different geolocation but going through United States proxies can mask your origin. And of course, that important thing, if I know that 40% of the attackers are coming from proxy, maybe I should react to that. Maybe I should block those proxies. Maybe I should do some more in-depth analysis on the traffic that comes from those proxies. It's an important thing. The second thing on SQL injection is I try to understand what are the tools that the attacker are using, and I was able to see that they're using SQL map and Avig. It wasn't so hard to do that. I was looking at the user agent, and that's what appeared there. And also, when looking at, well, the actual payloads that they send, so I can see in one case they are targeting WordPress users table. Someone is trying to steal, well, to penetrate into the WordPress users table and extract values out of that. In my case, my client, the client that I analyzed his data didn't have WordPress, so it was useless. But that is the kind of thing you can see that happens out there. And the second part here is, well, it's a trivial one, but someone is doing an uppercase, lowercase kind of payload injection. And that's, well, when someone using that, well, that means that he's a little bit more sophisticated than the common user. He's trying to do evasion. He's trying to see if the security filters has such capability to detect mixed uppercase, lowercases payloads. So that was what I have seen about SQL injection. But something is not working for me. OK. The second step was WebHive. As I showed you before, the application that once you logged into that application, you don't need to log, you just need to browse to that application. I put a different application, different snapshot of application, putting the target that you want to hit, pressing the start button. And by doing the analysis on 48 hours, I was able to find 23 different WebHive applications. This is the list of those applications. It is essentially very small. I don't try to share this information just because I don't want someone to abuse it, but the basic concept is that there are out there many web applications that are being used. Looking on distributed activities, 48 hours, I would try to find if there are all kinds of activities that are distributed. Well, I was able to see that there are 22 IP addresses originating from Indonesia, coming from the same telecom operator, sending SQL injection over a time frame of 36 hours. It was ongoing attack, right? Someone was probably reusing the resources of that network because it was blocked over and over again and got allocated different IPs, but I was able to see something that once looking at a single WAF trigger, a single event that just happened, I don't see that picture unless I'm doing analysis on that data. Now, I talked about the findings. Now let's talk about, well, the actionable intelligence, the thing that we just talked about. Well, first of all, I should do an IP blocking or subnet blocking in the case if someone coming from the same subnet. Maybe I should, for instance, do geolocation blocking. If I can see, for instance, that in the last 2 hours, someone is hitting my application from a specific country that I usually don't see traffic coming from that country, maybe I should, for the time being, block that country. Maybe I should block proxies, as we saw before. Well, maybe I should add all kind of ad hoc signature. We can add ad hoc signature looking at refer for domains that are not supposed to be there. In the case of WebHive, we can take all the information of the WebHive and put it into outbound filtering, putting their signature that my customer won't go, my clients in my organization won't get out of my organization to those domains. And when I'm talking about detecting targeted attacks, well, I should check and look at the SQL payload. I saw all kind of funny stuff that I analyzed those things, trying to figure out if my customer has WordPress or not. Well, maybe I should look at the source of the IP addresses, try to figure out where they are coming from. Maybe it's like a campaign that's been coming from proxies or from specific geolocation to my application. And, well, if it's an orchestrated attack, if it's something that generated by many IP addresses, I need to know that. I need to know if someone is doing denial of service on my organization. Is it one client that sent denial of service to my organization, or is it numerous IPs coming from different locations, sending a lot of traffic to my organization, and there is something common about them? Well, I want to know about it. I want to start doing better security if I know that. So my final slide is for today. Well, and this is, well, trying to talk about analysis and the reporting. And I gave you all kind of example of things that I was doing in the past and all kind of reports that I created in order to show customers, well, if it's a chai park or if it's something that's related to geographical maps or whether it's graph that show growth over time. These kind of things makes our work more visible to our executives and gives us a lot of benefits in the way that we present the thing that we are doing and help us, well, in order to get more resources from our executive. And that's important. So it was, I think, a little bit short, but if you have any questions, sure.
Could you elaborate a bit on the tools that you use to analyze your logs?
Okay. So actually doing that, it's, well, I wasn't using any specific tool. I was using tools that are being used as part of my organization. My organization take the logs and digest the HTTP traffic of what really happened and all the meta information that I have on those WAF triggers and put it in a database. And the only thing I was doing was querying the database. The only trick is to know which question you want to ask. That's a trick. There's a lot of technology behind it. It should be, but at the moment and the way that I was doing that, it was just asking the right questions. Someone else? Yes. Of course.
The attacks seem to be coming back from the botnets seem to be running the same piece of malicious software, right? That are sending the same attack. Why is the user agent different? Because I would assume those are like fake user agents.
They are fake, but that's exactly what really happens out there. The attacker knows that if you will correlate only the user agent, it will be an easy task for you. So what he's trying to do, and there are security filters today that correlate user agent and tell you, well, I'm seeing all kind of similarities in your user agent. That's why he has a list of user agents, and he random those user agents in his HTTP request, and this is the result. He's just trying to be smart. The next step, well, maybe he will change the actual payload, but that's more difficult from his perspective, and this is also something that you can try to find out if he's randomly creating all kind of payloads. Yeah.
Are you automating anything? Is there any sort of automation, like when you're taking any action after your
So this is, it's not a product. I'm not showing a product. I can say that I can tell about my experience and the things that I was doing. I was doing that, and I think in some of the things that I want to say in my summary, there's no doubt it should be a project. Maybe it should be an OWASP project that I would love to contribute to that project. I cannot lead this kind of project. I don't have the capacity to do that, but it can be a project that takes WAF triggers, put them into database, have the right queries and write the analysis on that, and get outputs that say, well, this is the action that you need to do. Maybe those outputs need to be action to mod security, telling, well, these are the dynamic signatures that need to be created, and these are the reason for that. Maybe the tool should create all kinds of CSVs and reports that will be used. It's a great idea. Yeah.
And the question in relation to the answer.
Okay.
Are there any plans to publicize some of these source IPs or what they were doing?
So earlier today we had, I don't know if you were in the Jacob West, it was from his CTO at HP, he was doing a lecture, and he actually talked about this issue, about creating a platform that, well, a community platform that everyone shares what really happens in their applications or network or whatever. And on that platform you get the right insight and the right understanding, because if someone is attacking you, maybe he's attacking someone else, and if both of you will share this information, well...
I mean, there are already some
yeah,
blacklists somewhere in the internet.
yeah, it's a huge project.
Also could contribute to or anybody else. They're not perfect yet.
Yeah. So I'm not sure if you're...
The question is this going to start a project where you, which is getting bigger, and you maybe could contribute either to those blacklists or collaborate with Jacob and do something like that?
Jacob works in a very large vendor, and he's doing that as being, well, I'm sure he's doing that as part of contributing to the community, but at the same time, it's probably would be an HP, well, profitable project. It's not it's not a small project. It can be done. I know that there are all kind of initiatives. I don't know what the status of those initiatives, but if someone can, pick the ball and do something about it, I would love to help.
Okay, good.
Someone else? So let me just summarize what I showed you today. And I showed you how you can take web application firewall, do analysis on the traffic on the triggers that created by the web application firewall, and do detection and mitigation, do analysis, and do reporting, and improve at the end of the day the security that we offer. And I think that's our ultimate goal. Thank you for today. If you have any question in the next day I will be here. Feel free to approach me.
almost. Today I'm going to be talking about a software implementation for botnet detection and well, based on Netflow IPFix output in a data center to determine the placement for autonomous VMs, among other things. My name is Razvan Ioandinica, Razvan. A little bit about myself. I've just over 7 years of programming experience. I've done PHP, Java, JavaScript, C, C++, Java, C#, Bash, Scala, just anything in between. I've done a lot of web programming so far. So my attempt at looking at data centers from a software point of view brought me over to Scala, the latest there. Be talking more about that. I've done some open source web development in the past, not a lot, but some. There's a project out there that I have. Mostly web and server development. I'm keen on ensuring application security from multiple points of view, as many as possible. Currently, I'm doing a PhD in cloud computing, expected January 2015, and at the moment, in parallel, I'm a lecturer at Anglia Ruskin here in Cambridge. Today, I'm going to be just brief outline, just what this is about, a bit about the cloud, what sort of test bed we're looking at, what we've used so far in our tests. Then I'm going to present an overview of the software approach I've taken. AMDS, that's an abbreviation of the software I've built. And I'll be talking more about that. I'm going to be looking at botnets, and then a bit of Netflow, IPFix, a very brief overview, and then the botnet detection module, which is the main aspect of today's talk. Then finally, the experimental design, what I've done towards testing this botnet detection module, and some of the results I've had so far, then a brief conclusion. What this is about, I'm going to be discussing autonomous software-based botnet detection, right? Something I've done as part of my PhD. It's built in Scala. It's deployed, or it's been deployed and is deployed on our testbed, cloud infrastructure, autonomous management distributed system, hence the name AMDS that I mentioned before. Bit of botnets, as I mentioned, botnet detection, and then the experiments. How many people here are experienced or are aware or have used the cloud or things in the cloud before, applications? All right, so you're aware of software as a service, platform, and infrastructure. You are? Everyone? Or? Certain level. Well, there's different levels, but the cloud, as a lot of people commonly refer to this thing here, right, this blurb, is composed actually of different components. Right? There's different levels of them. There's the software level, which is the very top, would be Google applications, for example, Gmail, and other similar services that you might have used. Platform as a service is one step deeper. It allows you to deploy your software, provides typically a set of APIs you can use, such as the Google App Engine. And then there's the infrastructure as a service, which is the lowest level in the cloud that allows you to deploy platforms, software. It gives you complete control, near complete control over the infrastructure level. So you could deploy your own operating system and then do things with that, multiple operating systems as virtual machines, and you have control over that. What we've been working with so far is we have hardware based in 4 different locations here on campus. We have 1 gigabyte and 10 gigabyte connections between, there's 1 gigabyte between the sites and then 10 gigabytes internally in in our data center. We have several servers, SANs, backup servers, multiple routers, switches, ILOs, and so on. Just a brief overview of what we're looking at. The several locations I've mentioned. The one at the top there, that's one location. And then we have two other rooms that just have a couple of servers each and a SAN. And then another room that has some more servers. And then there's a NetLab application there as well that we made use of to help with our tests. Then a bit of going one level deeper, one of our locations, our main data center. There's a switch at the top, there's some servers in between, and then there's our NAS that we look at, that we communicate with. Nothing unusual so far, just typical data center. My software approach was to have a modular application, highly extensible, that would make use of, and in this particular case, I made use of Java vSphere APIs, looking at VMware, a VMware-based data center, to plug into it and effectively assume some degree of control in an attempt to direct it a little bit to match our needs. And needs as different events happen around the data center in different points. It is highly scalable. It has load balance built in. And it does have security built in. As I mentioned, I'm keen on security, inner point-to-point. So the messages that get transmitted between itself and other instances and also inside itself, they're always checked. Make sure that none of the messages are compromised, coming from an unknown source. So don't trust those. It resides inside a Linux-based virtual machine, which provides a highly secure environment, potentially highly secure. Obviously, it depends on your configuration of it. But it's as secure as they get. Linux, you could just tighten security as much as you can in it. It does plug directly into existing infrastructure, making use of virtual networks to reach vSphere. And through that, the hypervisors themselves to issue commands. So this ensures an immediate threat response as needed along the way. And also through this, we have complete infrastructure control by using a piece of software. So we've directly plugged into the entire cloud infrastructure, which allows us to lock down individual elements. Just send a command over to vSphere, and its inner components, so we can directly control them through that. As I said, I've done this using Scala from multiple points, for multiple points of view, really. Because Scala, as compared to Java, it does have native thread management, fault tolerance built in, very easy to set up. You can achieve more. There's a control module which issues decisions, just looks at different things. Connection module, which ensures communication with other parts of the infrastructure, the database infrastructure, sorry, the data center infrastructure, other instances of itself. There's the storage that we look at, and then there's an SNMP module to ensure communication with network elements, such as routers, switches, ILOs, and so on. And then the one, another one for vSphere to communicate with, to interface with it. Then, where this talk here comes into, the botnet detection has been plugged into the existing infrastructure and just building on top of the existing design, just inheriting all of its features. Now, botnets, how many of you are familiar with botnets? Right, so everyone, good, good. Not going to go too much into this. Looking at Netflow, it allows internet access monitoring It's IETF standard, an IETF standard for data sampling and export, right? Security monitoring tool, flow timers. It allows you to see who, what, where, when, who it is, what it's doing, where it is, when it's doing it in the network. So allows traffic sampling for later analysis. Right. IPFix, very similar thing. It is based on Netflow. It does provide template-based flow exports, which was quite handy. Also, it does have an efficient data representation. Now, the botnet detection module itself, it is bolted onto the existing software, AMDS, the Autonomous Management Distributed System, as I mentioned before, which ensures that it does have access to the data center for management purposes. And also it ensures that, it does have the ability to instantly react to any detected threats, which effectively means that it can lock down the data center as needed, different points of access, restrict access throughout the data center itself, throughout the infrastructure, and also relocate sensitive virtual machines around to a more secure, locked down parts of the data center if a threat is detected. Now, in the grand scheme of things, looking at this, this diagram here, on the outside, there's the AMDS, right, the main software, and then everything in here that I've represented is the botnet detection module, which is the new part that I've designed. It does grab the flow from Netflow and IPFix through the connection module. It issues a request and then waits for data to come back to it. It stores it as it is for raw, as a raw flow for an admin analysis later on for a person potentially to have a look at. So we're not missing anything out. Every bit of data flow that comes from Netflow is stored for later viewing. There is another part of it which breaks down the flow. It looks at the different aspects of it. It looks at the IP address, the port, where it came from, what it needs to do. It looks at the command that is a part of it, just breaking it down for this other bit, which analyzes all of these components, the flow components. Then the result of the analysis is stored as well. And then this inner part here ensures communication with the outside world. So there is, if we go back to it very briefly, this other module that I haven't mentioned before, that just deals with the user interface, allows an administrator, a person, to have a look at what's going on and to monitor the situation. Yes?
This autonomous management distributed system is a system that you develop?
Yes.
And it's a VM layer, like hypervisor layer? Or what?
No, it's a piece of software that runs inside a Linux environment.
In a single VM?
Yes, a single VM.
Okay.
Potentially, sorry?
Like in kernel space? In kernel space?
No, it just uses the VM as an operational environment. It sits there. It uses it to reside, to exist, to run. It is a piece of software inherently.
Okay.
And it uses the VM as a starting point, right? And then it uses the virtual networks, the VLANs, to reach vSphere. That makes sense. Right? Yes, yeah. That's so it issues the commands. It looks for vSphere. It makes use of its Java API, which vSphere can expose internally, to issue commands to it. That makes sense. Right? So just getting back to this, that user interface module, as I said, allows the user to just view what's going on inside. So this flow reporting part of the botnet detection module it uses this part here to communicate with the user interface module of the entire AMDS system to provide its reports. Just going in a little bit deeper, just to put things into perspective. So this first bit, the network flow, just going to try and break down this diagram now. So we all know exactly what I'm talking about. So it does, as I mentioned, it does interface with the outside world. It requests and then waits for output from Netflow and IPFix. Then it passes them to storage and the breakdown module. The storage bit, it is long-term storage, local storage, so it is inside of it. AMDS, the software, controls the storage. So anything it captures, it locks down inside, and only authorized access can view what's going on in there. It does store raw flows and also the flow analysis results. Sorry. Do apologize. Ultimately, it responds to stat queries, statistic queries from the user interface module. Well, the one responsible for relaying information. So we'll see in a bit. The flow breakdown, as I mentioned, it deals with raw flow information, extracts key flow components such as packet size as well, the IP addresses and ports for both the source and the destination, the class of the service, what type of service it is, what device interface was used for this, protocol type, and so on. Then it passes these to the analysis component for further, for actually looking at it. The flow analysis bit, it uses a heuristic detection algorithm to identify malicious behavior by looking at it, as I mentioned before. It does compare the current flow to past flows to, in an attempt to identify irregularities.
When you say it goes to past flows, is that in what time period are you looking at? Is that from
the way
day 0 to
the way I've done it so far, it's looking at everything that it's captured so far. Try and keep things into perspective in an attempt to detect as many irregularities as possible. It does flag inconclusive results, so it just keeps them there. And in the storage, for later analysis after more similar flows perhaps have been identified in an attempt to detect malicious behavior. And as I mentioned, it does pass the results onto the storage. The algorithm itself, it allows a refinement of a client model from flow data. It looks at historical data flows in an attempt to build a client model to compare future flows against. This way, it tries to identify irregularities based on past results. It does require a training period beforehand of uncompromised access just to see what's going to get a feeling of what's going on. And then later on, any irregularities will be easily or more easily picked up by comparing to the regular flow, by looking at this client model that it's built in the past. As I mentioned before, it does consider all of these different aspects of the flow try and identify a pattern of what went on in the past comparing to what's going on now. I'll attempt to detect irregularities. Looking a bit deeper into it, I'm making use of the TCP workway that I haven't developed myself, but I'm making use of it. Looking at the SYN, SYNACS, FINs, and resets, and also a total number of packets that accompany the flow to try and detect irregularities. And this algorithm, the closer to 100% the result is, the higher probability that an anomaly exists within this, the current flow. The flow reporting component of this module, it is the user interface contact point, as I mentioned before, within the entire AMDS context. It is used to retrieve flow statistics as needed, and it provides a module activity overview. Very standard module. Now, looking at the experiments that I've done so far with it, I've used 10%, I sampled 10% of all network data flow, sorted the collected samples into logical groups based on their size, source, destination, and what commands they have. The packet sample size was set at 10% of all the traffic at the point of collection, with an average, as part of our tests, or we've used our packet size, or sizes between 500 and 1,000 bytes. We have sampled quite a few flows, and then after about the 500 sample, we started feeding it irregular flows to see what sort of detection rate it will have, to see if it manages to actually detect anything. In the grand scheme of things, the AMDS, which resides inside the infrastructure, as I mentioned before, it does make use of VLANs to communicate, to grab data, and then to also issue commands as needed. There's Netflow and IPFix, which are there to look at all the data that comes from the outside and goes inside to the different virtual machines that reside inside the infrastructure. And then, as I mentioned before, the AMDS issues commands to IPFix, and that configuration there, for a flow sample. Every now and then, issues a command, give me a sample. Then it looks at it, as I've shown you before. Now, what we've had so far, this first set over here at the top, the y-axis, the x-axis, the x-axis represents the number of samples that were taken, so as represented by time. So by sample 50, by sample 250, 500, and 1,000 samples. So these are flows that we've looked at across a period of time. Each of these samples average out around, so we've started light by sending 200,000 packets as part of the flow, and no infected ones, so no irregular ones, to try and just build up its detection algorithm, try and contribute to the model. The average size was around 500 bytes for the packets. And later on, very similar, Then at around 500, as I mentioned before, we started introducing some irregularities into the flows, see if it can detect them. And it did manage to detect about 28% around the first time we introduced it. Then as more and more packets, similar packets were sent, its detection rate increased. So by the time we got our 1,000 flow, it went up to 43%, detected of the entire infected packets that we sent. Just to sum up what I've presented so far, the botnet detection algorithm, or the botnet detection module design, I've designed it to be abstract, so it can be implemented using any sort of programming language at the user's discretion. As I mentioned before, I built this using Scala because of the various reasons. The more it runs, the better it gets. So the more it looks at in time, the more it can refine its existing model, looking at, to start with, looking at healthy packets. So a bit of a training period that it goes through. And then when it's actually put in a production environment, it is able to pick up on more and more irregularities. And this only improves in time. It does build towards a comprehensive botnet detection model based on the network flows, as I've shown you so far. And because of the way I've done it, using that AMDS software, which resides inside the infrastructure with direct access to vSphere, it is capable of real-time reaction to threats, trying to lock down key components, so just block access from the outside, look at where previous or similar-looking packets have gone through. So if at one point it will detect something, it will look at the history of flows to see if anything similar might have escaped it. Which, as I say, allows it to identify where the packets went and then just lock down those particular areas. Thank you. Any questions?
You show that you have a detection rate of 28% and 43%, which is pretty low to me. And the problem here, it seems that you rely on, basically your system is a kind of anomaly-based idea, so understanding. And you rely on the formula that you showed before, which computes basically the ratio of a number of packets having like CNAT or few, like set, based on the total number. But then experiment, if I understood correctly, experiment, you introduced, I think, a botnet.
Right.
Like a bot running. And usually a bot, what it does, just get some command, push out like data that are leaked, or update binary. And this is like kind of normal traffic, because normal communication traffic uses like push flags.
Right.
So it does not really hit the formula you showed before. So the feature you use here to detect malicious traffic, I think is too simple. Just use this one. You want to basically detect botnet. Sure. You will detect maybe, like all scan or scene flood or SM flood or service attack. But a bunch of other, malicious traffic you won't get it with this. It's too simple.
It is simple, but it is a different approach to what's been done so far. It is a software-based approach inside the data center itself to try and grab, plug into the existing.
This is engineering.
Right.
It's not research. I mean, if you deploy solution in a cloud or in a normal network,
Okay.
Another
All right.
thing you didn't show is the ratio you have of false positive. So you didn't basically test for false positive.
You're correct there. I didn't test for that. I tried to see how many of the infected flows that I've made generate, that I generated. I tried to see how many it could detect using this. And then based on the findings, just refine it as we go along.
Yeah, you should use an experiment called train test, where basically you train your classifier based on the flow that are equal 50, 100, everyone, and then you test it, and you have basically with the table where you have the different false positives, you have detection rate.
Okay.
If you don't compare your detection with the number of false positives, basically the results are perfectly attributed.
Okay. Well, thank you for that. No, it's completely fine. This is just at the beginning. The main aspect of what I've been doing so far was the AMDS thing. Then recently I started looking at how I could detect botnet activity. This is where I chose to start at. Right. Well, there's always ways of improving work, definitely always.
Do you think this would be a scalable solution in terms of detection? Because it strikes me that you're going to get a lot of information. If you put this out on a normal website or what have you, you're going to have a
Right.
problem is that you say you need to know what normal traffic looks like. You're not going to be able to know what normal traffic looks like in order to train it. Because you don't know whether or not it's been under attack at that point in time anyway.
Right.
It could be a low-level attack or what have you.
Okay.
So, do you think, how do you think you could scale it, potentially? Or do you think that, sorry, I'm just trying to get a feel for
Right, no.
where your research is going to go.
Okay.
In terms of where you think the next steps are. It's coming from more production or business aware approach is, can you scale this? This goes back to my question of
Right.
how much data you're looking to retain.
Okay.
From day zero to current day, you'll
Right.
get to a point where you'll have so much data you won't be able to sort it or actually process it in a effective time scale.
That makes sense. Yep, thank you for that. What I've tried to do so far was build a proof of concept. I have not yet considered its true scalability in a fully production environment, as you mentioned. Very fair assessment. But going forward, once a model has been established, so there is, as I mentioned, that training period which needs to happen. After that happens, then you can just use the model to just look at new traffic rather than comparing it to everything historically, absolutely everything you had in the past. This can work quite well up to a certain point, as you mentioned.
Do you think you'll get a tail off in terms of your detection rate given your sample size? So do you think if you increase your sample size, you're going to get to a finite level, or it will continue to grow in terms of its detection rate?
So far, it has gone well. The more we ran it, the more we left it to do some things, the better it got. And I do understand that this is a low rate, but being a different approach to this, using existing algorithms, but a different approach, uses this software to create this botnet detection module, botnet detection model that can be used for future traffic. But until that can happen, this initial model needs to be constructed. But then, afterwards, then it will not need to look at past records. It will just look at current, future.
Yeah, I agree with the previous comments.
Okay.
I like the architecture, so and I know why you use Scala, but I don't think you should focus on like a particular, just mean, detecting bot traffic it's hard problem, right? I mean, just to give you an example of people that you might see with a training mode, and that we were doing some research on this, and so we were training this model on like white traffic, so something that we consider was not compromised. And okay, so the problem is like on our corporate network, you have such a variety of traffics. And at some point we were looking like beaconing, right? So we found like beaconing, so that's quite cool. So we like with the frequency sort of analysis components, we were saying, oh, this node is beaconing, and then okay, we did some investigation, and of course it was like a weather app. So somebody was saying a weather app, it was beaconing frequently, and
Right.
the same Netflow behavior that you can see from a bot, right?
Okay.
So there is not a single silver bullet that you can use. So you need to, like, I don't believe just looking at, like, by personal experience, by looking just at Netflow data, you won't get a high accuracy. Even doing like stateful inspection, Netflow data, and the with a little policy kind of modeling, so you know that that particular traffic is used for, like, I don't know, for a specific business logic. I didn't see, well, in the literature as well, I didn't see anything that was reaching like high accuracy, high precision. I think you're better off fighting your battle. It would be like high precision and low recall. So like you're like in terms of statistics, you can say, okay, I'm pretty sure that this kind of behavior, this specific behavior, it's 100% off, right? Rather than saying, well, I'm pretty sure like 50% of these 10,000 bits are Botnet behavior, because then the analyst would say, I mean, from an operational point of view, like you can't have people like doing investigating like 10,000 bits every day. So it's a hard thing to do. I mean, there is research, and then there is the operational side. But yeah, I think you have to explore more options and see.
No, definitely, completely agree with you there. I did not present this as a one-stop solution, just the holy grail. It's something I started doing. So it is in its infancy, really. So I've started looking at, but definitely there are so many more ways of doing this, and other ways that you could use in conjuncture with this to try and determine for certainty, although even that you'll never be able to fully certain, I guess, say that is a botnet. Because as you said, you could have the one-off weather app that could just generate some weird traffic. They say, oh, botnet, but not really.
Maybe the network was already compromised, so you learn on something that was compromised, so you can see, or you learn like something that like it's really hard to say even like policy-wise. Like the company might say, oh, you're not allowed to use peer-to-peer apps. And then you have like employees using peer-to-peer apps.
Right.
And then you say, oh well, is that kind of normal behavior, or is that So there are so many cases that it's really hard to.
Oh.
But yeah,
definitely.
Consider, like,
you need boundaries.
Yeah.
Thank you. Thank you.